Hello all, my name is Krishnaik and welcome to my YouTube channel. So guys, we have something very amazing for you all. Implementation of an end-to-end deep learning project with deployment with the help of GitHub Actions, MLflow and DVC and a lot of MLOps tools that will probably be used in this specific deep learning project. Again, the main intention is basically to provide you an idea that how an entire end-to-end deep learning project is implemented, what all tools are specifically required, how to probably create the pipelining concepts, how to train your model, and many more things. So yes, please do go ahead and enjoy this specific video. Again guys, unless and until you don't prepare well, you will not be able to implement it. So my suggestion would be that please try to implement completely end to end. All the written materials, I mean the code and everything will be given in the description of this particular video. So yes, go ahead and enjoy this specific video.
Hi guys, welcome to this end-to-end project implementation video. In this video, we'll be implementing one amazing project called end-to-end kidney disease classification using MLflow and DVC. So here you will be also learning how we can integrate various kinds of MLOps tool with these kinds of end-to-end implementation. So guys, if you are already following end-to-end implementation from this channel, so you already know actually we have already done lots of end-to-end implementation in this particular playlist. So guys, previously we implemented one machine learning project with the help of MLflow. So many of you have already requested try to integrate this MLflow with the deep learning project as well. So that's why actually we brought this project implementation called end-to-end kidney disease classification using MLflow and DVC. So guys, here I'm not going to show you the MLflow integration. Apart from that, I will also show you how we can create these kinds of DVC pipeline. And what is the advantage of DVC pipeline? I will discuss each and everything. You don't need to worry about. So guys, make sure you have already subscribed to this channel to get always notified with the new upload. So guys, before starting with this implementation, one particular things actually you need to know, which is nothing but MLflow. See, if you already know MLflow, it's completely fine. You can skip this part. But those who doesn't know about MLflow, so there is a dedicated video from this channel actually we'll see here. This is the video actually. This MLflow tutorial. So just go ahead and watch this video. So you will get each and every idea about the MLflow, like how we can use MLflow, what is the MLflow and all about, okay, why we should use MLflow, how to connect with these kinds of DAG-sum and all, okay. Everything you will be learning from here because I will be referring this particular video for the implementation itself. So I'm not going to discuss this MLflow and all because this video is already created in this playlist. So just go ahead and check it out. Now guys, let's get back our agenda for this video. So here guys, first of all, I will start with the introduction of this project. And I will start with the GitHub repository setup because whenever you are starting with any kinds of end-to-end project implementation, the first thing we always do, we set up our GitHub repository to maintain our code actually. Let's say you are implementing one project in your local system and there is a chance actually you might lose that code, okay, by crashing your system and all. So it's better practice always just try to push that particular code to the GitHub so that if you're losing your system also, if your system is also crashing, it's completely fine. You will still able to get the code from the GitHub itself. Then guys, I will start with our project template creation because I always follow one particular template with any kinds of end-to-end project implementation. I think you have already seen. So here I will be creating one particular template of this project. So there actually I will be organizing lots of folders and file. And that folders and files actually how we'll be organizing using Python code. I will be showing you each and everything from this video itself. Then guys, I will start with our project setup and requirement installation because we need lots of requirements. We need lots of libraries in this project. So if you want to install these are the libraries and package in your local system, you should have the environment ready. So we'll be seeing like how we can create the environment, how we can set up these kinds of requirements. Everything I'll be discussing about. Then guys, I'll be discussing about three major components in any kinds of end-to-end project, which is nothing but our logging module, utils module and exception module. I'll tell you like what is the use of this module, okay, so that actually you will be getting familiar with and you will be also using these are the component in your project implementation. Then guys, I will be discussing about the project overflows because whenever I start any kinds of end-to-end project, actually I organize lots of folders and file. So now one particular question would be in your mind, like which file I need to change first, which file I need to change last year in this case. So that is why understanding this project workflows is very much important. What I feel like whenever you are trying to implement any kinds of end-to-end project, okay. Then I will show you all the components notebook experiment. Let's say whenever I will be starting our components, okay, let's say data ingestion, then model preparation, okay, model evaluation. Okay, so these are the thing before starting writing our modular coding. I will first of all show you with the notebook experiment, like the way we usually perform any kinds of data science project in our Jupyter notebook. So first of all, I will tell you like how we can perform. These are the component experiment on our Jupyter notebook. Then once you got familiar with the Jupyter notebook implementation, I will try to convert this thing as a one modular coding implementation so that it would be very much helpful for you to understand the code. Then guys, I will start with our all component modular coding implementation, as I already told you. Then I will start with our training pipeline. Okay. Then guys, after that, what I will try to do, I will try to integrate MLflow. So this is one MLOps tool. I think you already know. So here I will try to use MLflow for the experiment tracking and our model registration part. Okay. So guys, what is experiment tracking and what is model registration? If you want to learn it, just go ahead and check that particular video I already showed you. Then guys, I will try to integrate DVC. So this is another kinds of MLOps tool. So we'll be using this DVC for the pipeline tracking and implementation. Okay, so what is the use of this pipeline tracking and this implementation? I will discuss whenever I will try to show you the DVC one. Okay, why we can't create like simple pipeline? Okay, what is the issue with that simple pipeline? I will discuss each and everything here. Then guys, I will try to create our prediction pipeline, because once you have done with your training pipeline, you also need the prediction pipeline, because here user will give some data and they will expect some prediction from your model. So this prediction pipeline we need to create. And apart from that, I will be creating one user app, so that actually user will get one user interface there. They will give the data, and from there itself, they will get the prediction. Okay, instead of giving our raw code. Then guys, I will try to integrate Docker with that, because here I'm going to follow the CICD deployment, okay, on the AWS cloud. So if you want to perform this CICD, that means continuous integration and continuous delivery deployment, you need this Docker integration with your code as well. Okay. So yes guys, this is the complete agenda in this video. So I'll request everyone, just try to stay with the video, try to see each and every component implementation, as well as you just also try to implement with me, so that actually you will be learning a lot. And guys, this is my promise. If you can implement this kinds of end-to-end project, okay, so there is a 100% chance actually you will be cracking any kinds of data science interview. It's my guarantee to everyone. So make sure you just watch this video till the end and try to implement this project with me. Okay. And if you face any kinds of issue, if you face any kinds of installation issue, just comment it out, so that I will look into it and I will try to help you with that. So yes guys, this is the agenda from this video. Now let's start with our implementation. Guys, before starting with our implementation, first of all, I want to tell you some of the prerequisite for this video. So here I'm expecting you are already familiar with Python programming language. At least you know the object-oriented concept, okay? Because here I will be using modular coding. So there actually I'll be using Python class and all. So I'm expecting you already familiar with Python object-oriented programming. Then I'm expecting you have some knowledge on deep learning, let's say at least object classification task. And you should have knowledge on the basics TensorFlow 2.x API. So basically here I will be using Keras from the TensorFlow itself, so that you will be implementing this thing in an easy way. And if you know like how to create neural network and how to load, these are the pre-trained model in TensorFlow and all, I think that should be enough knowledge for this video. Then guys, you should have the AWS account ready, because here I already told you I'll be hosting my app to the AWS cloud. So that's why AWS cloud is needed here. And fourth, like one very important things, actually you should have the dedication. Let's say if you are only watching this particular video, so that won't help you ever. So you always need to implement something from your side. You need to put your dedication on, so that everything you will be able to understand. Now guys, let's start with our project introduction, like what is kidney disease classification and all. Okay, so here basically I'll be using kidney CT scan images. As you can see, this is my kidney CT scan image. So right hand side you can see this is my normal kidney. Okay, so this is the CT scan image of our kidney, and you can see there is no tumor present, okay, in this kidney, because this kidney is completely fine here. So as you can see, but if you compare with this tumor kidney, okay, this is the CT scan of the tumor kidney. So here you will see some of the brightest color, and see, this is the actually tumor, okay, present in the kidney, and this kidney is completely fine. That's why we are calling this kidney as normal, and this kidney is not normal because here if you see there is a tumor present, okay, in this kidney. So this is our actually task we'll be performing, and this is the dataset actually I'll be using. I'll share this dataset with you, and I will also show you like from where you can download this dataset and all, okay. So that actually you can also start downloading from here, and you can do it with me. Otherwise you can also use my dataset because I have already provided the link of my dataset. Now guys, what is kidney tumors? I think you already know. If you don't know, let's give a brief definition of kidney tumors. Kidney tumors are also called renal tumors, okay, and are growth in the kidneys that can be benign and cancerous, okay. So it will occur unexpectedly, okay. You don't even know like you got kidney tumor or not, okay. So it would be completely unexpected. So this is nothing but our kidney tumors, okay. This is the definition you can talk about. Now I hope you got some idea about this project, like what kinds of problem statement we are trying to solve. So this is the problem statement we are solving in the medical domain. So those who are working in a medical domain, this is the best project for them actually. But if you're also fresher and applying for jobs, you can also mention this project in your resume. It's completely fine. So guys, yes, this is all about from my side. Now let's start with our implementation. So at the very first, what I will do, I'll try to set up my GitHub repository. So guys, the first thing you need to do, just logging with your GitHub account, and here just try to create one GitHub repository. So guys, as you can see, I already created one GitHub repository called Kidney Disease Classification Deep Learning Project. Okay, this is my repository. So in this repository, I'll be committing my code. And if you don't know how to create the repository, just go to your GitHub and click on the repository. And here you will see this button called new. Okay, just click on the new, and here just put the name and all. Okay, and just add the readme file and create the repository. Okay, so if you do it, so you will get this kinds of window. So if you're getting this kinds of window, it's completely fine. Now what you can do, just click on the code and copy this HTTP link address. Okay, I will copy this HTTP link address, then I will open my local folder. So this is my local folder. So here what I will do, I will try to open my terminal. Okay, so you can also open up your git bash or anaconda prompt, whatever terminal you're using, you can open this one. So here I have already opened my git bash here. Now what I will do, I'll just write one command called git clone. Okay, if I just write git clone and paste this link, so it will clone this repository here. So let me show you. See guys, it has already cloned this repository. So this is the repository guys, Kidney Disease Classification Deep Learning Project. Now I'll go inside that cd Kidney Disease Classification Deep Learning Project. Okay, now guys, I am inside this folder. Now here what I will do, I will open up my VS Code here. So in this case, you can open up your VS Code or any kinds of code editor you are using. Let's see if you are also using PyCharm, it's completely fine. You can open up, okay, here. So to open the VS Code here, just write code space dot. This is the command. So if you just execute this command, it will open up the VS Code here. So guys, I already opened up my VS Code. Now let me close these are the thing. Now I'll also close this welcome screen. So the first thing what I will do, I'll try to create one template file here, because I already told you I will be creating one project structure. So to create this structure, I need one template file. Okay, I don't want to create these files and folder manually using this button and all, because if you are doing it, so it will take lots of time, and it is like a time taking task, and there actually you need to do lots of hard work. So I don't want that. So as a programmer, we always will be using Python programming language to do anything. Okay, so here I'll be writing one Python script to create this folder structure, and it would be just one time effort. Okay, and if you're able to create this file, so by using this file, you can create the folder structure anytime by executing the same file. Okay, so here just click on this button and just name this as template.py. Okay, so this is the template.py file I'll be creating. So here the first thing I'll be importing this operating system package. With that, I also need pathlib. Okay, so I'll just import. So I think I should import like that from pathlib. So inside pathlib, there is a function you will get called path. Okay, why? So guys, here why I need this path class, I will tell you. Okay, why I'll be using this one. And I also need logging. Okay, so this three packages actually I need to create this template.py. So the first thing what I need to do, I need to create one logging string here. So let me comment out. I just need to create one login string. Okay, why I need this logging string? Because whenever you will be executing this template.py file, so what are the activity actually this file will do? Let's say it is creating the folders and all. This kinds of message actually will be able to see from your terminal itself. Okay, instead of printing that actually operation, what you can do, you can log them. Okay, so this is pretty much better practice whenever you are implementing any kinds of end-to-end project. Instead of using print statement everywhere, try to use this log statement. Okay, logging statement, and for this actually you need one logging string. So how we can create the logging string? So this is basically one logging string I usually follow in my every project. So guys, I think you can see. So logging dot basic info. So this is the function you need to use. Inside that, you just need to specify the log label name. Okay. So here I want to only log the information related log. Okay. Like what are the information? Actually, it will give me that information related log I want to print inside my terminal. Okay. And here I'm also specifying the format of the log. Like what is the format would be our log. Okay. So guys, here I'm following one particular format. So first of all, it will extract the ASCII time, the current timestamp you are executing your code. With that, the logging message actually you'll be giving. Okay, so I will show you like whenever I will print this log. Okay, I will show you like how it is printing the log and all. So once it is done, you just need to write the project name right now. Project equal to, so I'll just write project underscore name, and here just specify the project name. So here I'm going to create one classification system here, like image classification system here. So instead of writing our project name here, what I can do, I can give one a template name called CNN classifier. Okay, why I'm giving this template name? Because you don't need to change this every time. Okay, because you already know we are doing a CNN classified here. So instead of you can also give like kidney disease classification, it's completely fine, but I just kept as a template. So because if you learn just one implementation, if you have this one template, you can use this template in your every project. Okay, that is why I'm creating this name. Okay, it's completely fine. Now let's say my project name would be CNN classifier, and it will classify this teamwork, okay, from the kidney itself. And I need to create some list of the file here. Okay, list of the files and folder. Okay, so I already prepared some list of the files and folder here. Let me show you. See guys, in a Python list, you just need to specify these are the files and folder. Okay, so first thing what I will do, I will create one .github folder. Okay, inside that I will be creating one folder called workflows. Okay, inside that I'm creating one file called .gitkeep. Why I'm creating this .gitkeep? Because whenever, let's say, you are committing your code in the GitHub, if your folder is empty, so it won't consider, okay, it won't be uploaded that folder in the GitHub. So it should have some file present in the folder. So that is why I'm keeping this .gitkeep file, because there is no use this file. Okay, that is why I'm keeping. So whenever I'll be creating my CICD pipeline, okay, at that time I will remove this file and I will create my CICD component there. Okay, because I already told you here I will be following CICD for the deployment, and for the CICD deployment, you need one particular file called main.yaml. Okay, inside that you will be mentioning all the commands. So that file I'll be creating later on here. All right. Then I'm creating one folder called source called src. Why this source is important? Because let's say if I visit any kinds of DL framework repository. Okay, let's say I will visit Keras GitHub. Let's visit our Keras GitHub and see like how they have implemented their code here. If you see here, this is the Keras and this is the project name actually. Okay, inside that if you see, they have created lots of component. Okay, let's say activation, then application, backend, callbacks. These are the thing they have created. Let's say in future they need some more functionality. So what they will do, they will open this folder and they will write the code inside that. Okay, so what will happen? So see guys, in such a way they are arranging the code so that in future they need some other component they can add very easily here. Let's say I want to remove some functionality from here, I can easily remove from here. Okay, so that is why always we just need to follow this structure. Okay, so instead of writing Keras here, I'm writing called source. Okay, src. That means I am considering this folder name as src. Inside that I will be creating all of my components. Okay, so that is why if I show you my code here, I will be creating one src folder. Inside that I will be creating my project name. Okay, and inside that I'll be creating all the components. Let's say data ingestion, model preparation, model training, everything I'll be creating inside that. Okay, then I need utility file. Okay, here if you see, they're also using utility file here, utils. Okay, so what would be present inside utils I'll be discussing, don't worry about. Then config, configuration, pipeline, entity, constant. Okay, so these are the actually component I need in my project. So what these are the file actually why we need it. I will discuss each and everything. First of all, let me create them. Okay, as of now, just consider these are the folders and file I need in this particular problem statement. Okay, in this particular project. Now I need this config.yaml DVC, because I already told you I'll be using DVC and all. Params.yaml, requirement.txt, setup.py, then as research. Okay, inside research I'll be creating all of my Jupyter notebook experiment. Okay, then here I'm going to use a Flask framework to create our web app. That's why this template and this index.html file is needed here. Okay, so this is the complete list actually I will be creating here, and these are the folders and file as of now I need. And if I need anything later on, I can add it here. Okay, just give a comma here, just give a comma here and just write the folder or file name here. It will automatically create. Okay, I'll show you like how it will create. Now what would be the logic for creating these files and folder here? Okay, so this is a simple Python code actually you just need to write. Okay, so let me show you what is the code is here. You just need to write here. So guys, here I'll be using one for loop. So if you see, this is a simple Python for loop I have created. So first of all, I am indexing through this list here. If you see, I'm taking the record one by one. Then here I'm providing this complete path. If you see, this is the path here I'm using /. This one I'm passing inside path class. Okay, why I'm providing inside path class? Because if you already know Windows operating system, it supports this /. Okay, if you see any kinds of path, it will always follow this /. Okay, not the /. But here in this project we have mentioned something called /. Okay, so what will happen if you're not giving this entire path, okay, to this path class? So it will throw one error. I am not able to find this file here. Okay, it will throw one path error. Okay, because Windows doesn't know this / and all. Sometimes it may work, but some of the system I have seen like it will throw error. But it will completely work fine with the Mac and Linux system. Okay, so those who are using Mac and Linux system, it will work completely fine from them. You don't need to give inside the path, but I'm giving inside the path because I want to make this code as very robust, so that if you're executing this project in any kinds of operating system, it will support. Okay, that is why you always need to think about in such a way whenever you are creating any kinds of project, that project should be running inside every operating system. Okay, you need to write robust code always. Okay, production grade code always. That is why. So that's why what I'm giving this path one by one inside this path class. It will convert this path to our Windows. Okay, first of all, it will detect what kinds of operating system you are using. Let's say in this case I'm using Windows operating system. It will automatically convert this path to the Windows operating system and it will give me that. Okay, so that I won't be facing any kinds of path issue. That is why I am importing this path from the path lib itself. I think you got it right now. Then what I'm doing, I'm separating out. If you see here I have my folders. Okay, this is my folders, and with that I have also file. Okay, so here if you see, this is my folders, this is my file. Again, this is my folders. Okay, till this point, actually this is my folders, this is my file. Okay, so I'm separating out my folders path and my file name. Okay, here if you see, using west.split, if I give this complete path here, so what it will do, it will separate out this folder for me and it will separate out this file for me automatically, and a folder will come inside this variable, file will come inside this variable. Okay, once I get it, so whenever I got this folders and files, so the first thing I will be creating my folder. Okay, so to create the folder, I can use west.make directories. There is a method inside operating system package. So here it will take this folder directory. Okay, and one parameter you just need to provide called exist. Okay, is equal to true. Let's say this folder is already present, it won't be creating, otherwise it will create. And once it is created, I'm just logging my information. I'm calling my log string logging dot info, and here I'm giving one message creating the directory to this file directory. Okay, for this the file of this file. Okay, so this is the message actually I'm printing in my terminal. That's it. Now once my folder got created, I also need to create my file. Okay, here I mentioned my file, and the file where I'm getting, I'm file inside file name. Okay, so here I'm again calling if not this west.path exists this file path. Okay, if this file is not present in my directory and this file size is 0, okay, then I'll be creating the file. Here if you see, I'm just using with open. Inside that I'm giving my file path, so it will create the file for me. And here I'm just logging the information, file has been created here. Okay, and if everything is fine, if everything is fine, my files and folders are already present. So I'm giving one condition here, else everything is already exist here. Okay, so this is the simple Python code, guys, I have already written. Okay, there is nothing rocket science I'm doing. It's a simple Python code I have written to create the file and folder structure in my directory. That's it. Okay, now let me execute and show you how it will look like here. So what I will do, I will open my terminal, and here, first of all, let me clear it. Let me zoom a little bit. Okay, so here the command I need to write called Python template.py. Okay, so if I execute this command, guys, you will see the magic. See, left hand side there is nothing right now. So if I execute this command, you will see it will create all the folders and file for me here. Okay, now let me show you. If I execute it, see guys, also if you see, it is giving the logging message like creating directories, these directories. Okay, creating directories, these directories. So the way actually I set my login string, it is giving like that only. See, first of all, it is extracting my current timestamp. Okay, because I have mentioned the ASCII time. With respect to that, the message actually I want to print here. If you see the message I have given here, this message, okay, this message is also printing here, creating directories and all. Okay, now left hand side, if I show you, see, all the files and folder has been created automatically here. Okay, now see, this is my .github folder. Inside that I have workflows. Okay, then inside that I have .gitkeep file. Then this is the PyTest folder automatically created for me because I'm using PyTest extension from VS Code. This thing won't be coming for you. Okay, so it's completely fine. You can remove this. Okay, there is no use of this file. Okay, now there is a config file has been also created, config folder. If you see, inside that I have config.yaml. Then resource, I have trials.ipynb. Then src, inside src, if you see, it has created the folder with my project name called CNN classifier. And inside that I have my components, config, constant, entity, pipeline, utils, and everything. Okay, and what is this components, config, constant, entity, pipeline? I will be discussing each and everything. You don't need to worry about. Then guys, if you see here, it has also created the templates folder. With respect to that, it has also created that index.html file for me, because I already told you I will be using something called Flask package to create our entire web application. And for this, actually, I need this template folder present in my project. Now here, with respect to that, guys, you can see it has also created my requirement.txt file. So here I will be mentioning all of the requirement package I will be using for this project implementation. With that, the setup.py and my yeah. So these are the thing only, I think you already know. Now guys, let's say I want to create another file here. Okay, I want to create another file here. So I'll just give comma in this list and mention it here. Let's say I want to create something called test.py. Test.py. Okay, that's it. So I'll add it and save it. I'll open my terminal. Then I'll just execute the same command again called python template.py. Okay, now if I execute it, see guys, see the magic? It has automatically created this test.py for me, even without replacing. These are the thing actually. Let's say if you have some code inside this files and folder, it won't be replacing. It will ignore that one because I mentioned this logic here. This file should be completely size would be 0. If you're mentioning some code inside the file, so this side won't be completely 0. That's why it will be ignoring, and it will create the only file you want in this list. Okay, that's it. Now I'll be removing this thing because I don't need test file here. I'll also remove from here. So guys, I hope this thing is clear, how to create this template.py file and all. And I got my folder structure and file here. So the first thing what I will do, I will commit these are the changes in my GitHub. So for this, I will open my terminal again and let me clear everything. So here I will just write git add space dot. Then I will just write git commit hyphen m. Just give the message here. So folder structure added, folder structure added. Then I will just push this thing in my GitHub. So I'll just write git push origin main. Okay, so because this is my main branch, as you can see, now let me push it. It's done, guys. Now if I go to my GitHub here, and if I refresh this page, see guys, my folder structure has been added here. So now what I will do, I need to set up my environment, and I also need to install the requirements here. So again, I will go back to my code. Let me close this template.py here, and let me just show you what are the requirements actually I'll be using here. So guys, here if you see, I need these are the requirements to execute this project and all. So the first thing I will be installing TensorFlow, okay, and the TensorFlow version I will be using called 2.12.0. This is the specific version actually I will be using for this implementation. So it always better practice whenever you are using any kinds of package, okay, that is updating frequently. You should mention the version of it. Okay, let's say if you're sharing this project with anyone else after 1 year, okay, later. So what will happen actually, if you're not mentioning this version, it will install the current TensorFlow version, and there would be some functionality which has been already deprecated in this current TensorFlow version. So your project will fail there. But if you're mentioning the specific version, it won't be failing because it will be using that particular version only to execute this other project. Okay, then I will be using pandas DVC, okay, this data version control package, because I already told you I'll be using DVC in this project. Then guys, I also mentioned MLflow, and this is the MLflow version 2.2.2. I also need to integrate MLflow. That's why MLflow I also need to install here. Then guys, these are the some basics packages I think you are already familiar with, like Notebook, NumPy, Matplotlib, Seaborn, okay. And I will discuss this Python box. What is this Python box and all? I will discuss detailedly why I need it, and this is the specific version I will be using. Then PyYAML I need, because here if you see I'm using YAML file to so guys, to read the YAML file and load it in my code, actually I need this package, okay. Then TQDM, ensure, I'll be also discussing the ensure, why I need the ensure and all. Then joblib, then type PyML, okay. These are some you can say additional package I need, and this is my Flask and Flask core, because I already told you I'll be using Flask for creating my web app. And gdown I need here because I will be reading my data from my Google Drive. So how to read the data from the Google Drive itself, I will show you with the help of this gdown package. And at the very last, I have mentioned something called -e space dot. Okay, so why I have written this one, because I want to install this folder as my local package, because I will be importing something, let's say from src.cnn classifier, I want to import, let's say, data ingestion. Okay, so if you want to import like that, actually you just need to install this folder as my local package. How it will consider this folder as my local package? It will find out this constructor file __init__.py. If it is present, if you see inside every folder I have this constructor file, okay, so that's why it will be install my local package automatically with the help of this setup.py. So in this setup.py you need to mention some of the code. Let me show you what are the code actually you need to mention. See guys, this is the code actually you need to mention here inside setup.py. Okay, so first of all you will be reading your readme.md. This is not necessary, but you should read it, because this thing will help you whenever you are publishing this project as PyPy package. At that time this thing is needed. Okay, let's say here long back I hosted one package here. Let me show you, called image seeker PyPy. So this is the package actually I developed. So it is hosted on this PyPy website, and if you see, there are some description you can see about this project. So how this description is coming? With the help of this this code actually. Okay, it will load my readme.md and it will print everything there. Okay, so that is why actually you need to write this thing. Then here you need to specify the version of the project. So it is the very initial phase of our project, so that's why I've given 0.0.0. The repo name, okay, so let me see my repo name here. It's kidney disease classification deep learning project. I will copy the repo name, and here I should provide the repo name. Let me do it. Okay, then you can specify the author name. Okay, you can specify the author name or GitHub username. So in this case, let's say this is the user, Krishnaik06. I'll just copy this username from here. Let me open in a new tab. Then I will open my code again, and let's say this is the user. Fine. This is the username of the GitHub, and this is the source repo. Okay, source repo means this is the project name you have created inside src folder called CNN classifier. Okay, and you can mention your email address here. Okay, you can mention your email address here, and this code will remain same for everyone, guys. This is the code actually. It will look for this constructor file, and it will install as my local package. That's it, guys. Okay, now let me save it, and let me show you how it will install my package actually. So for this, what I will do, I will open my terminal again, and here the first thing you need to create one virtual environment. So to create the virtual environment, just write this command conda -n, just specify the version name. Let's say here I am doing kidney disease, so I'll just name it as kidney. You can give any name. So here you just need to specify the Python version. So Python equal to I'll be using 3.8. Okay, you can use any version, but 3.8 I'll be suggesting use this one, and -y. So this is the command, guys. Now let me execute this code. It's done, guys. Now let me clear my terminal. Okay, so now what I will do, I have already created the environment. Now let me activate it. So just write conda activate. My name was like kidney. Done. Okay, so now I need to install the requirements here. So to install the requirement.txt, just write this command pip install -r and requirement.txt. So it might take some time to install this package. So in between, what I will do, I will update all the commands inside the readme.md so that you can refer. So here, this is the steps to run this project. First of all, you need to clone the repository. So let me just give the repository link. This is the repository link. Let me just go inside. And here, this is the link of the repository. Then you need to create one environment. So let's say this is my environment I have created. Then you need to activate it. Then you need to install the requirement.txt. Okay. Now, if you want to see it, like how it will look like in the README, just open it and just click on open preview. Okay. If you click on, you will see like how it will look like. See, this is the command you just need to copy from here. Now let me close it. Okay. And I will wait for the installation. So guys, as you can see, my installation is done. So everything is fine. There is no error. That means congratulations, you have done the setup of your project. Now we are almost done to our implementation. So what I will do, I'll quickly commit these changes in my GitHub. Let me just quickly do it. See, if you don't want to write the command from here, what you can do, if you're using VS Code, there is a option you will get called source control. So what you can do, just left hand side, you will see one option called source control. Just click here. And now you can see these are the file you have made the changes, and this is ready for commit. Okay. So here you just need to specify the commit message. Let's say I have added my requirements here. So requirements added. Then I'll just click on commit. See guys, it has been committed. Now it is asking for sync changes. Okay. Sync changes means it will push the code in your GitHub. See, push. So it will ask for some authentication if you're doing at the very first. So it may ask you logging with your GitHub and all. Just do it. Okay. Once you have done this, so next time it won't be asking, you can directly push the changes. So let me show you. So if I click here, so see guys, it will push the changes in my GitHub from the VS Code only. I don't need to write the command again and again. Now if I go back and refresh this page here, see guys, this is my last commit I have done, called requirements added. Okay, so that's how you can do. And this is my readme, guys. I have updated. Okay, how to execute this project and all. So yes guys, we have done the project setup. Now let me go back to my VS Code. So guys, we have completed our requirement installation and project setup. So now what I'm going to do, as I already told you, we need to create some like very important module called logging, exception and utils, because these three things we need before starting with our implementation. So what I will do, first of all, I will show you like how we can create the logging module. Then I'll show you like what is the technique I'll be using to handle the exception and all. Then I'll be finally creating my utils module. Okay. So to create the logging module, so just expand this src folder, and inside that you have this CNN classifier, okay, or project folder name. So inside that, if you see one constructor file I have created called __init__.py. Okay. So what you can do actually, either you can create one folder called logging. Inside that you can create the logging functionality. Okay. But today the technique actually I'm going to use, it would be a little bit different. So why I'm going to use this technique, I will show you because it will help you to do the import operation very easily. Okay. So because see, logging module I'll be importing in every component. Okay, every component I'll be implementing. So again and again import from the folder itself. I'll just keep this inside my constructor file inside my project folder, and from here only I can easily import that. So how we can do it? So let me open this constructor file. Okay, now here I already created one logging functionality, guys. Just let me show you. This is a simple Python logging functionality I've just created. So here basically I'm using these three packages, WES, then system, okay, and Python inbuilt logging. I think you already know, using Python inbuilt logging we can create our custom logging on top of it, right? And this is my logging string I have created. And what is the logging string? First of all, it will store your ASCII time, the current timestamp you will be running your project. Then it will store your log label name, okay, like what kinds of log actually you want to store. So basically I'm going to store information level log, okay, and this is the module name, like which module you are running this file. Let's say I'm running this let's say template.py, or let's say data ingestion.py, okay. So it will give that module actually I'm running this code, and then it will print the message like from where you are getting the error, okay, what it has been executed, all the messages I'll be defining, everything I can get from here. So this is my complete logging string I have prepared, and it would be very much clear whenever I'll be executing the entire code. Okay, now first of all it will create one log folder here. Okay, basically if you see here, it will create one there is no log folder, so it will create one log folder. Inside that it will create one running log file. Okay, so this log file it will created, and inside this file it will save all the log information. Okay, and if you see here, using wes.make directories I'm creating this folder. Then after that I'm defining my logging functionality. Here if you see, I'm using basic config, and inside that actually I'm defining my log label name, and my format is nothing by my login string I have defined, and this is my handler. Okay, basically I'm telling I also want to get the file, this log file also I want to see in my terminal. Okay, that's why I'm giving system.sd out. Basically it will print all the log inside your terminal as well. And at the last, what I'm providing, I'm creating one logger objects, and this is the name of the logger object. That's it. Okay, now guys, let me show you how it will work. So for this, what I will do, I will come here and I will create one file called main.py. Okay, let me create it, main.py. Fine. So first of all, I will import this log here. So first of all, what I need to do, I need to first of all import this logger. Okay, import this logger inside my main.py. So how I can import it, I'll just write from src. Okay, if I write from src, then i.cnn classifier, then inside that I can do import logger. Okay, that's how I can do it. Now let's say I will give some log here, so I'll just write logger dot info, and let's give some message. Let's say welcome to our custom log, or let's say custom let's give our custom log. Okay, this is the message, let's say I want to print. Now if I execute this code, see, it will work fine here. Okay, it will work fine, but I will do some modification here. So let me clear my terminal first of all. So I'll just write python main.py. Okay, I will execute my main.py file. Now guys, see, it has given me the log message. Okay, see, first of all, it is extracting the ASCII time, the current timestamp, then the log level, okay, information related log, and it is running from main.py. If you see here, I have run main.py, that's why main.py is coming, and this is the log message actually I have given, welcome to our custom log. That's it. Now if you go to your folder, and left hand side you can see Wolf folder has been created called logs. Now if I expand it, see, running logs has been also created. Now let's open this one. See, the same message you can see here. Okay, so basically you can also see from the terminal itself, and it is also available as a log file. So what will happen actually after like productionize this application, you won't be getting any terminal to see the logs, like what is happening in your code. So at the time, what you can do, you can download this log file, and you can see what has happened in your code, it is running fine or not. Okay, let's say you got one bugs in your code, you can easily look into it here, and you can fix from here. Okay, so that's why this log file is very much important. Now guys, see why I have written my log file inside that, okay, instead of creating a logger folder here, because let's do some modification here. Now let's say if I remove this src folder right now here, and if I again execute this logging file main.py, see, again it has executed, and there is another message. Okay, it's running fine, but although see, it is present inside my src folder, I didn't mention my src folder here. Okay, because if you see here, I already installed, if I open my setup.py, I already installed this CNN classifier. That means this folder as my local package. Okay, in my Python environment, this folder is already considering as my local package. That is why in this folder, what are the files and what are the folders are available, I can access anything from here. Okay, instead of mentioning this src folder. So that is the advantage of writing this logging functionality here. Okay, instead of writing logger folder separately. So if I'm writing logger folder separately, so what I need to do, I need to again just write here from src dot logger from src.cnn classifier.logger, then import logger. Okay, so it would be pretty much bigger, you can say import operation. So that is why I have mentioned inside that. Okay, so this is another technique I usually follow whenever I try to create any kinds of end-to-end project, guys. Okay, you can follow, either you can create one login functionality here, it's up to you. Okay, so I'll be following this technique here. So yes guys, I hope this logging is clear. Okay, like how I have created this logging functionality and what is the use of this logging functionality and how we can use it in our code, right? Now what I will do, logging functionality is done. Now I will be creating my exception. Okay, exception, like let's say if I get any kinds of exception, so where I'm getting the exception, what kinds of exception I am getting, everything I can see from there. So to create the exception, I will be using my utils folder. Okay, because yeah, here I will be using something called box exception. Okay, box exception instead of writing our custom exception, because there is a package called python box. I think you see here python box. So using this package, actually I will be creating the exception. Okay, and not only exception, I will be creating some more functionality here. I'll be telling you like what are the things I'll be creating here. Now here inside this utils folder, I'll be creating one file called common.py. Okay, because here I'll be keeping all of my common code. That's why I'm naming this file like that. Now let me close the mail logging and setup.py and requirement.txt as well. Now guys, here the first thing actually what I need to do, I'll be importing some of the libraries here. So let me first of all show you what are the things I need here. See guys, so these are the libraries actually I need here. Okay, so I'm importing operating system, then I'm importing this box. Okay, as I already told you, I'll be using something called box exception array. So this is the box value adder. Okay, this is the class I'll be using. Then YAML I need, because I also need to read the YAML file. Then I'm importing my logger. Okay, the way I showed you, CNN classify import logger. Then JSON I need, joblib I need. Okay, then ensure. See, some of the package I'm importing extra, you can also remove it. It's there is no issue with that. Then I'm also using ensure. Okay, ensure annotation. So what is the ensure annotation I'll be talking about? You don't need to worry about. Then I'm also importing this box. Okay, this config box. So what is the use of config box? I'll be discussing about. You don't need to worry about. Detailedly I'll be discussing this thing. Then path, I think you know what is the use of the path. Okay, to handle this Windows path and all. Then typing. Then base 64 string. So why I need base 64 string, I'll be talking about. Now guys, these are the import actually I need. Now here in this common.py, okay, what I need to keep guys. So here I'll be keeping all of the common code actually I'll be using throughout my entire project. So let me show you what are the things actually you need to keep here. Yes, so these are the function actually I'll be using in my entire code actually. So all of the functionality I won't be using, some of them actually I'll be not using, but I kept it just for your reference. Let's say if you need this function in any kinds of project, you can refer from here, because this is the common file I usually create in my every project. Now guys, see, the first function I'll be using something called read YAML, because as I already told you, I'll be using YAML file, and inside the YAML file I'll be writing some content. So so to read the content actually I need this read YAML function. So what I will give, I'll give this YAML file path only, and it will give me the entire content inside that. Okay, that is the use of this YAML file. Okay, so this is the function guys. I have written this function, and it's like very simple function I have written. Okay, see, I'm using this YAML file, then I'm loading the YAML file, then I'm logging the information like this file has loaded successfully, then I'm returning the content of it. Okay, and what is the content type? It's box config box type output. Okay, here if you see, this function type is config box. So in Python you can also define the function return type, like what would be the return type. Okay, so this is another function in Python. If you don't know, just try to learn from here. So you can also define the return format. Okay, like what would be the return format, okay, from this function. So, and what kinds of input you want to take in this function, that type also you can mention here. Okay, so that's why we can write a production grade code. Now what is config box type return, I will discussing this thing, no need to worry about. Then here I'm also writing create directories, because I will be creating some of the directories here. Let's say artifacts, inside artifacts I'll be creating data ingestion, data validation, right? So to create these are the folder, I need this create directories. So basically here I will be giving my directories name, it will be automatically created for here. So see, let's say if I'm not writing these are the functionality separately, so what will happen, in each and every component I need to write them as a separately. Okay, like every time I need to write the same function again and again, so it will increase my code. Okay, so guys, to write a efficient code we always need to follow this technique. So those functionality we will be using frequently in our code, instead of writing them separately, I can keep it inside my utils functionality, that means utility functionality. So whenever I need it, I will be reading from here only. That is the idea of this utility file. I hope this thing is clear right now. Now save JSON. Let's say if you want to save any kinds of JSON file, I need it during model evaluation, because I want to save my model metrics as JSON format. That's why I need it. Okay, so basically it will take the JSON file path and it will save it. Then load JSON, if you want to, let's say, load the JSON, you can do it, but I won't be using in my code. Then save bins. Let's say if you want to save any file as a binary format, you can use it. Then let's say that particular file you can load it using this load bin. Then if you want to, let's say, get any kinds of size of a file, you can use this function. Then decode image and encode image. Okay, what is the use of decode image and encode image? I'll be discussing whenever I'll be creating the prediction pipeline and user app. Okay, that's that time I'll be discussing this thing, why I need it. Okay, user will upload the image and they will get the prediction. So what is the use of this decode and encode image functionality? Fine. So guys, as of now, let's consider these are the functionality I only need in my code. Okay, I only need in my code to prevent this frequent writing function. Okay, now here on top of every function, if you see, I have defined this ensure annotation decorator. Why I have defined ensure annotation decorator? So now let me discuss this ensure annotation and this config box. Okay, what is the use of this one? So to explain this thing, what I will do, I will open this trials.ipynb file. Yeah, because this is my notebook file I have created inside research. So here I'll be doing all of the experiment. So here, the first thing what I will do, I will connect my kernel. So let me select the kernel, Python environment. And here, this is my environment, kidney. Okay, so this environment I'm using here. Okay, it's fine. Now let me save it, everything. Okay, now what I will do, first of all, I'll be defining one dictionary. Okay, so see, first of all, I'll be discussing this config box, then I'll be discussing this ensure annotation one. Okay, so now let me discuss the config box. Okay, so here, let me comment it out. Config box. Config box. Fine. So first of all, let me define one dictionary here. So let's say this is my dictionary. So inside that I have some key value. So let's write some key value. So this is my, let's say, key. So this is my, let's say, value 1. Value. Okay, I can write it like that, key val. And again, I can write another key. Let's say key 1 and my value 1. Fine. Let's say this is my Python dictionary, simple dictionary. Now let me execute. So now one question, just write it down in the comment. So let's say if I want to, access this value. Okay, if I want to access this value, or let's say if I want to print this value, so what I need to do here? Okay, in dictionary. So I think you already got it. You just need to do like that, the way actually we perform in our dictionary. So what I will do, I'll just write D, then I will try to access the key here. Let me copy the key and let me execute it. Now see, I'm getting the value. Now let's say if I want this value 1, so what I will do, I will call my key 1. Very simple operation we have learned in your dictionary. Now can I access is like that, instead of writing this key like that, if I call it like that, let's say key, can I do it? Just write in the comment. Now let me execute and show you what will happen. See, if I call this key, it's telling attribute error. Okay, this dict object has no attribute key. Now let's say if I also want to call this key 1, again the same error I'm getting, because I can't access like that ever in this Python dictionary. I need to access like that. This is the format, right? But what will happen, let's say whenever I'm returning this like YAML file output, it will return every time as a Python dictionary. Okay, Python dictionary. And again, if I want to access these are the value, I need to write like that. But this is like very, like you can say, time taking task. Okay, again, you just to mention the bracket inside that you need to write the keys and all. So it would be very much difficult for you to organize that one. Okay, so instead of that, can I do it like that? Just I will call my dictionary object and I will call the key name. Okay, I will call the key name and it will give me the value. Can I do it? Yes, I can do it using something called Python box. Okay, now let me import this Python box. So for box, import config box. So let me first of all import this library. Yes. Now what I will do, I'll copy the same key. I'll copy the same dictionary, and here I will write another dictionary object d2. And now instead of writing this as a Python dictionary, I will provide inside my config box. Okay, I'll provide inside my config box. Now see the magic, guys. Okay, now if I execute it, see it has run. Now if I just call d2 dot, let's say I want to access this value. Okay, so I'll call this key. I'll call this key. Now see the magic, guys. See, now it is printing. Okay, now let's see if you want to see this value 1. So I'll call this key 1. Call this key 1. Now see, value 1 is printing. So see, the way we study in our Python dictionary, we have converted this easiest way. Now we can easily access any kinds of value from this dictionary itself, because now if you see d2, if you see the d2 type of d2, it's a config box type actually. Sorry, type of d2. Now it is a box, a config box type, basically config box type actually type. But if you see the d, let's say if I print a type of d, you will see it's a simple dictionary dict object. Okay, so this is the use of this like config box. So why I need it, I think you got it, because everywhere if you see, whenever I'm reading YAML file, I'm returning as a config box, so that whenever it is giving the simple Python dictionary, I'm converting to config box so that I can access like that. Okay, this would be very much clear whenever I'll be using this one. Okay, now this was all about my config box. Now let me discuss something called annotation. Ensure annotation. Okay, so what is ensure annotation? So here, first of all, I'll be defining one function called def. Let me define it quickly. So here I have already defined one function. So guys, this is the function. So this function actually will take two values, x and y, and this should be integer type, and it will also return as an integer type output, because if you, let's say, multiply integer with integer, so you will get integer type. Okay, so this is one get product function I have created. It will only take two values and it will do the product of it, and it will return. That's it. Okay, this is a simple Python function I have created. Now what I will do, I'll execute this function, and inside that I'll provide two values. Okay, so first value, x is equal to, let's say I'll give 2, and y is equal to I'll give, let's say, 3. Okay, now if I execute it, see, it's giving me answer. Okay, it's completely fine. But you will see one thing here. Although I've provided this input should be integer, but let's say if I give a string with that, okay, instead of giving 3 as integer, I will give 3 as string right now. Now let's see what will happen. See guys, still it is running and it is giving 33. Okay, now I think you are getting it. It is printing this 3 two times. Okay, because it is multiplying this 3 two times, if you know Python basics, string multiplication. But see guys, the issue is, like I have already mentioned, this function input type should be integer, but if I'm giving string also, it is accepting. There is no issue with that. Still I'm getting output. So let's say if you're writing a bigger code and at that time you have done this kinds of mistake and you are getting unexpected output, so what will happen? You will get mad, right? So what is happening in my code? So to prevent this kinds of small issue, small bugs, actually, what you can do, you can use one package called ensure annotation. Okay, so what is the ensure annotation? What it will do? Now let me show you the magic. So first of all, I will import my ensure annotation. Now what I will do, I will copy the same function I have created from here. Okay, so on top of it, I will just only mention this decorator, okay, called ensure annotation. That's it. Okay, now let me execute it again. Now I will call the first call of my function. It will work fine, I know, but let's say if I try to call my second call right now, which is using my string, now see, it will throw the error. See, it's throwing at the error argument y of type class string, but no function get see, it should be integer type. Okay, this is the error it's giving. Now see guys, using this simple one decorator, I can prevent this kinds of error. Okay, now see, I can easily get it get to know like what is happening. Okay, what is the input I'm trying to give here. Okay, so this is another good package actually. I have recently just learned it. Okay, I recently just got this package, and I thought let's integrate with my project so that you can fix these kinds of issue. Okay, now I think you got it, like why I'm defining this ensure annotation every year, because if you see, I'm defining data type. Okay, every time I'm defining my data type, like what kinds of data type this function will take. Okay, so yes guys, this is all about our box error, and this our config box, and this one your ensure annotation. And why I'm defining my box error, So here, if you see here, everywhere I'm giving this box value error, so it will raise me the exception every time, okay, instead of writing our custom exception. So now, yes guys, it's done. So what I will do, I will quickly commit the changes because we have created our logger exception and utils, okay, both we have created. Now I'll quickly make the changes here. So let's say I'll just give utils added here, utils add. Fine. Now let me commit. So guys, it's done. Now let me show you whether it is updated or not. I will go to my GitHub and refresh the page. So see guys, it has been updated here. Okay. So now what I will do, I will give you the project workflows idea. Okay. Let me open my code again and let me go back and open this readme.md. Okay. So what would be the project workflows idea? Because I already told you here, I have already created lots of files and folder. Okay. Now before starting with our implementation, first of all I need to know which file I need to change very fast, which file I need to change very last. Okay, because there would be a flow I'll be following in this project implementation. So now let me show you what is the workflows actually I'll be following. So I've already written the workflows here. So here, just let me add it. Yeah, so guys, this is my project overflows workflows. Now let me just otherwise you can keep it here. So see, first of all I'll be upgrading my config.yaml file. Okay, here if you see I have config.yaml file, this file I'll be upgrading very fast. Okay, then if you have any secret.yaml file, let's say if you are using database and any kinds of secret information which you don't want to share with your like you can say user, so at that time you can keep these are the thing inside secret.yaml. But in this project I haven't created any kinds of secret.yaml. This is completely optional. Let's say if you are creating the secret.yaml, you need to upgrade that file. Okay, you can remove it as well, it's completely fine. Then I'll be updating my params.yaml. As you can see, params.yaml is there. Then I'll update my entity. If you see inside src, I've created the entity folder. This entity I need to update. And what is entity I'll be talking about, no need to worry. Then I'll be updating something called configuration manager in src config. Okay, see here inside src, I have created another config folder. Inside that I have one configuration.py. So this file I need to upgrade. Okay, then after that I will be upgrading my components. See, this is my component. Inside that I'll be upgrading my data ingestion, my model preparation, okay, model trainer, model evaluation. These are the thing I need to upgrade. Now I need to upgrade my pipeline. If you see here, I have created the pipeline. So this pipeline I'm upgrading. I will be creating my training pipeline as well as my prediction pipeline. Then after that I'll be upgrade my main.py. Okay, main.py. This means this is my main.py and this is going to be our endpoints. Okay, and here I'll be upgrading my dvc.yaml. Okay, so dvc.yaml at the last very last I'll be upgrading because this is going to be tracking your pipeline. Okay, entire pipeline. Then at the very last I'll be creating another route here whenever I will creating the user app called app.py. So this app.py I'll be updating at the very last. Okay, so this is the complete workflows I have created, guys. This 10th workflows I'll be following, and one by one I'll be upgrading and I will show you like how this project will look like. Okay, so I hope you get some idea right now like how we will be following our entire project overflow and all. Now what I will do, I'll quickly make the commit again. So here I'll just write workflows, add it, commit. So guys, as you can see, it's done. Now next step what I will do, so guys, now I will start with our first component, which is nothing but data ingestion. So basically in this component we'll be ingesting the data. First of all, let me show you the data, guys, like how this data look like. So guys, see, this is the CT scan kidney image. Okay, so this is the kidney CT scan image I collected, and this is the normal kidney of the CT scan image. You can see here, these are the normal kidney. If you just open it one, see, this is the image. That's how it will look like. Okay, so we have lots of images here, around 240, and with that actually I also have one tumor. Okay, tumor kidney CT scan image. Okay, if you see here, so this is the tumor. These are the tumor actually. So this is the data set I will be using in this project, and from where you can download the data set. So this data set you will be getting from the internet only. Just write kidney CT scan image data. If you just write, actually you will get lots of image. Even you will get this Kaggle. Okay, just to visit Kaggle, and from Kaggle also you can download this data set. Okay, as a zip file. It is also available there. So I already collected this data set. If you see here, it is available in my folder. I will provide this data set with you so that you can use my data set. And if you see here, this training image is very less here. It's around 225. Whenever you are trying to create any kinds of real application, at that time you need to increase the data amount because only 200 images won't be working. But here I'm giving you the demo. That's why I'm using only 200 data, because I want the quick training, okay, from my system. So that's why I kept this 200 image around. But whenever you are training your own model, just try with use dataset, okay. And from where you can download from Kaggle itself, okay. I already showed you like how to download it. Now what you need to do here, see, after preparing your dataset, so see, this is the folder you need to create. Normal, inside that you need to keep all the normal image. Then tumor, you need to keep all the tumor image, okay. Then what you need to do, you need to zip the data, okay. You just need to zip the data. So what you can do, see, let's say this is my folder. Just make a zip file. Okay. See, if you're using 7-zip, so using 7-zip you can make a zip file, and after making it zip file, you need to upload it in your Google Drive, okay. So why I'm uploading in my Google Drive, because see, today actually I'll show you how you can read the data from the Google Drive itself. Let's say I have huge amount of data and it is not possible to keep in my GitHub, or let's say any other place. So that's why I will be using Google Drive, because Google Drive is a free. You can either keep this data in the inside S3 bucket and all, okay, in any kinds of database. It's completely fine, but again, you need to pay for it. But I don't want to use like any kinds of paid services. That is why I will be using free services, okay, as much as I can. So that's why, guys, I will show you like how we can read the data from the Google Drive itself. So here, guys, if you see, I already updated this kidney CT scan image zip file in my Google Drive, okay. So after uploading in Google Drive, you just need to copy the link address, okay. Just click on share, copy the link, and make sure you have given the access to anyone with this link. Otherwise it won't be working. So see, just give the access with the anyone with this link, then copy the link address, okay. This copy the link, and this is your data link. If I show you, see, this is my entire data link. So now this data link, you just save it somewhere, because we'll be using this link to download our data from the Google Drive itself, okay. Let me go to my code, and here, before starting with our component, I just want to show you how we can download the data from the Google Drive itself, okay. So for this, we'll be writing one small script here. So first of all, let me comment out here, download data from G Drive. Okay, so here the first thing I need to import something called gdown, okay, gdown package, because this is the package we'll be using to download the data from the Google Drive. And I think you already remember, we already installed this in our requirement, okay, gdown. So that's why I can import it directly from here. Now let me zoom a little bit. Yeah, import gdown. Then let me import it. Okay. Then first of all, I need the URL. Actually, I prepared. So URL. So URL equal to, I will copy this URL. I think you remember we copied the URL from our Google Drive. Okay, this is the data URL. Now here, I'll just paste it. Fine. So this is my complete URL. Now what I need to do here, if you see any kinds of like Google Drive link, okay, you will see one ID, unique ID, any kinds of file. If you copy any kinds of file from Google Drive, okay, let's say if you copy this file also, this file also, you will see this unique ID would be changing every time. So this is the unique ID. We can access that particular file present in my Google Drive, okay, and this is the Google Drive link. Like https drive.com Google, okay, this is the link. With that, this is the ID, and this is the like access you have provided. Okay, now what I need to do, I need to somehow access this particular ID. I need to somehow extract this particular ID, and I will create another URL, okay, called prefix. With that, I will add it, and I will download my data from the Google Drive itself. Okay, how we can get this ID? So here I can write one simple logic. I'll just write URL dot split. Okay, this is just a string slicing operation I need to do. So here I need to slice my string with this slash. Okay, that means forward slash. Now if I do it, see, it will give me all of the words actually separated by this slash. Okay, now see, http google-drive.com. Now I need this one. Okay, so I need the second last one. So how I can access it? If I write it like that, -2. Now I think it should give me the ID. Yeah, so this is the ID I got. Now we'll store this ID in a variable called file underscore id. Fine. Now if I print this file underscore id, now see guys, this is my id I got. Now what I will do, I will define one prefix URL. So what is prefix URL? Prefix URL is a download URL actually, a Google Drive use. So if you want to, let's say, download any kinds of file, let's say I will download this file, I will double click. Now if you click on download, okay, if you click on download, it will generate this prefix URL every time. Okay, it will download this, generate this prefix URL, and it will need the ID actually, this ID, which which file you want to download from the Google Drive. Okay, this ID, if I add it here, so it will download the particular file from my Google Drive. Now what I will do, this is my prefix ID. Now I'll just write here one simple logic. Let me show you. See guys, this is my prefix ID, and with that I'm just calling gdown.download, and with the prefix ID I'm adding my file ID. This ID I'm adding, that means it will come here, and I'm giving the name, like what should be the name of the zip file. Okay, because this is a zip file I'm downloading, and what is the name of the zip file? It's a CT scan. I get the CT scan image. You can also change the name, any name you can give here. So let's give CT scan image. Okay, otherwise let's give kidney CT scan image. Okay, this is the name I want to download. Now if I execute the code, you will see the magic. It will download that particular file from my Google Drive. See, it's downloading, and it's around 57 MB. Now this is the progress bar you can see. Okay, so that's how very easily we can read the data from the Google Drive itself without any kinds of cost. Okay, so you don't need to add any kinds of database here. You can, because in Google Drive you will get lots of space, so you can utilize that one. So guys, if you see here, it has downloaded my dataset here in the research folder, this kidney CT scan zip file. Okay, now we are able to successfully download the data, and see, either you can use my URL to download the data, it will work fine. Otherwise you can also upload your data in your Google Drive. Okay, both will work fine. So yes guys, I will use this logic to download our data. Like whenever I will be creating this data ingestion component, I'll be use the same logic, but I will be doing some modular coding here. I need to prepare some config component. These are the thing. Okay, then I'll be starting with my data ingestion. Now to start with our data ingestion, the first thing what I will do, I will open my config.yaml. Okay, so inside config.yaml, first of all you need to define some of the variable. Okay, what are the variables you need to define? Let me show you. Here first of all I need to define for my data ingestion related variable. See, these are the data ingestion related config I need. Okay, this is the artifact root I have given. Artifact root is nothing but, let's say whenever I will be downloading my data, okay, it will save inside one folder, because see, this is the experiment I showed you. But whenever you are creating your actual component, okay, that component will generate some of the artifacts. Okay, that artifacts I will be saving inside the artifacts folder. So basically it will create one folder here, artifacts. Inside that it will create another folder called data ingestion. Okay, if you see a root directory is my data ingestion. Inside that I have provided my source URL, which is nothing but my data URL, the URL I copied from my Google Drive. Now whenever I will download the dataset, it will download as data.zip inside my data ingestion folder. Okay, then whenever I'll unzip the data, it will present inside my data ingestion folder. So that is why this artifacts folder is needed. Inside artifacts I'll be creating one particular component called data ingestion. Inside that I will ingest my data. Okay, that is the logic. That is why these are the variable I have kept inside config.yaml, so that I don't need to hard code the value in my component. So let's say in future I'm changing my data URL. I will just open this config.yaml file. I'll change the URL here and it will reflect in my every code. I don't need to change the particular component. Okay, so that's why instead of hard coding those value, you can keep it as a configuration, okay, in a particular YAML file, and you can do the management from here only. Okay, so that is why we create this config.yaml file. I hope this thing is clear. Now let's say if I do my model training, I will keep my model training related configuration here. Let's say number of epochs, batch size, so that I can come here, I can change the parameter from here only. Okay, that is the use of this config.yaml file. Now what I will do, I have already prepared this config.yaml. Now here let's start with our the first component, which is nothing but data ingestion. So inside research folder I'll be creating another file, and I'll name it as 01 data ingestion dot ipynb. So this is the name, because this is a notebook file. So first thing I will connect my kernel. Yeah, first of all let me close. These are the thing, actually I don't need it. Yes, so here the first thing I will import operating system module, because I'll show you why I need it. Now see, if I do my pwd project working directory, so see, I'm inside the research folder. Okay, I'm inside research folder. Now what I need to do, see, if I want to create the artifacts folder, I need to go back. I need to go back here. Let me show you. Let me open my folder. See, now I'm currently inside this folder, but I want to create the folder here. Okay, in this project directory. So I need to go back to my project directory. So how I can go back to my project directory? So in operating system package, there is a method you will get called chdir. That means change directory. So here you just need to provide this particular symbol dot dot slash. Okay, if you give it, so it will go back just one particular folder back. Okay, now let me show you. Now if I again do pwd here, see, I'm inside currently my deep learning project. Okay, that means kidney disease classification deep learning project. I'm inside this only. Okay, so guys, now what I need to do, I think you remember we have given one project workflows in my readme. So first of all, I need to update my config.yaml. I have already updated. Secret I don't have, I would be updating. Params, yes, I need to update the params, but initially I won't be keeping anything inside params, but I will give some dummy value. So let's say key and val. I'll only give this one, because if you leave it completely empty, then it will throw error. That's why I'm giving some dummy value. Whenever I will prepare my model, at that time I will give the parameter. So as of now, let's keep the dummy value only. Now params we have updated. Now I'll update my entity. So now what is entity? So see, I already created the entity folder here, but here I'm doing notebook experiment. Okay, that's why I won't be adding entity in my modular coding. As of now, I'll be creating everything inside my notebook, then I'll be adding. Okay, now what is entity, guys? Let me show you. Entity is nothing but it's a return type of any function. Okay, see, this is the return type of my data ingestion function. Okay, so what is the return type? Return type should be like, it will return my root directory, which is nothing but this is root directory, and it will return my source URL, all the thing I have mentioned in my config.yaml, everything it will return one by one. See, okay, then local data file and unzip file. And what is the data type of it? So this is the path type, so I have defined as path. This is string, that's why I have defined as string. Again, this is a path, this is a path, that's why I have defined. And what is this data class? Data class is a, like you can say, a decorator you can assign on top of any Python class, so it will consider as a entity. Okay, it will consider as a, like, it won't be a Python like class, it will be kinds of, you can say, class variable, so you can access these are the variable from the other file as well. Okay, that is the use of this data class, or you can say this entity. Now I will explain this entity, like how we'll be using this entity. As of now, let's consider what are the things I have defined inside my config.yaml. Okay, so everything I need to return here as a variable, okay, inside this class only. Now guys, what I will do, I'll quickly execute this entity. So this is my entity part. Now here I need to import two things. I think you remember we have created one constant file, okay, constant folder. So inside that I have one constructor file. Let me open up this one. So why I need this constant folder? Because if you see here, I have two YAML file. One is my config.yaml, another is my params.yaml. So these two YAML file I need to read. Okay, then I need to return, right? But to get the path, actually, I can provide the path inside my constant. Okay, so because this path would be constant, I won't be changing. Okay, see, this is my path, config file path. So here I'm giving path because it will handle this Windows like issue. This is my config.yaml is present inside config/config.yaml. Okay, so this is the path and this is the variable I'm storing inside that. And this is my params part. Okay, params.yaml. Okay, so these two paths I will be returning inside my constant. Okay, this constant I have created. Now here I'll be importing these two paths. So what I can do, I'll be just writing from CNN classifier dot constant. Okay, it is present inside the constant. As you can see, I have already defined dot constants import star. Okay, that means whatever variable I have defined here, import everything here. Okay, that is star represents. Now with that, I also need to import some of the utility function from my utils folder. So I'll just write from CNN classifier dot utils, because here, if you know, I have created utils. So utils, inside that I have one file called common, and from here I will import readyaml and this create directories. Okay, these two methods. So let me import read YAML and my create directories. Okay, these two function I will be importing from my common okay, common.py, because these two function I need, okay, in this component. Now let me import them. Yes. Now if I go back to my readme.md, so we have already prepared our entity. As you can see, entity is prepared. Now what I need to do, I need to update my configuration manager in src config. So here if you see, I have configuration.py inside config folder. So I need to upgrade this file, but here I will be doing inside the notebook. So that's why I need to update here. So here I'll be creating one class called configuration manager. Let me show you. So this is the class I have created called configuration manager. Inside that I have created one constructor, and in this constructor, I think you remember, we are returning two paths here. One is my config file path, another is my params file path. Okay, so these two paths I'm initializing here in this class variable. As you can see, config file path and params file path. Okay, now using this readyaml function, I'm reading this two file, my config.yaml and my params.yaml, and it is storing inside this two variable. Okay, the first thing what I will need to do, I think you remember, inside config I have prepared this thing, artifacts root. Okay, artifacts root, as you can see, artifacts root. Okay, here this is the artifacts root, this is the key name. So first of all, I'm creating one directory is self.artifacts root, because it will return as what? It will return as dictionary. I think I showed you this trials.ipnb here. Okay, it will return as my config box. Okay, and I can access any kinds of key. Let's say I want this key, I want this value, I'll call this key. Okay, and I will get the value. The same thing I'm doing here. So it will return, these are the thing as a key value pair. So I'm just calling this key, that means artifacts root, and it will return me the value. Okay, and that value is nothing but it's a folder name, and it would be created, okay, using this create directories, because create directories will take any kinds of directory name and it will create that directory here. Okay, so that is why I'm calling this config.artifacts root. So, and I'm passing inside create directories, and it will create the artifacts folder here. Okay, now this is the configuration manager class. Now inside that I need to prepare my data ingestion related configuration. Okay, now let me show you how I prepared my data ingestion related configuration. See guys, here I have defined one method called get data ingestion config. Okay, now this is the return type of this function. Okay, the return type where I have prepared, I prepared here. See, this is the return type, one entity I have prepared, right? So this is the entity. So I'm telling this function will only return, these are the value. Okay, these are the variable. Apart from that, it won't be returning anything. If you write extra thing, it will throw error, because this function is only responsible for returning these are the value only. Okay, so that's how you can define any kinds of return type of any kinds of function. Okay, the way we did, I think you remember here inside my commons. Okay, see, it will only return config box type output. Okay, it will only return here, I think, config box type output. Okay, so that's how, see, it will only return string type output. So that's how you can define any kinds of return type of any kinds of function, okay, using this entity. Now I think you got it, but that entity I was using like pre-built entity, but here we have created our custom entity. Okay, you can create custom entity using data class, and we have already created our entity, and that entity I have defined as my function return type. Okay, now inside that, what I am doing, first of all I am extracting my data ingestion related configuration. That is basically, this is the key. So if I call it, so it will return these are the configuration, and I'm storing one by one. First of all, the root directories. Okay, root directories, as you can see, config.root directories, those are root directories. Then source URL data file unzip directory. Okay, source URL data file unzip directory. So these are the thing it will only return. Okay, because data ingestion I've already done, because here I have given data ingestion config, so it will only have these are the function only. Now at the end, I'm just returning. Basically, this is the technique I'll be following to management our entire variable, okay, in my project. Okay, instead of writing them hard code, now I can get this like config easily by calling this configuration manager. Okay, anytime I need it, I will call this class and I will access these are the thing only, right? Now let me execute quickly, and this should be pretty much clear whenever I will execute the entire component, and you will get the idea. Okay, now guys, we have completed our let me close this constant, I don't need. Now let me show you, I need to update my component. Okay, component is nothing but our data ingestion component. Okay, now again, I won't be updating inside here. I will be doing inside my notebook, because after doing the notebook, I'll convert it my modular coding. Now to prepare the component, first of all, you need to import some of the libraries. Okay, so these are the libraries are needed. I first of all need this operating system package. Then I think I don't need this request package. This is the extra thing I have added. Then I need this zip file, because it will give me the zip file. Okay, after ingesting the data, then I need to unzip that file also. That's why zip file package I'll be using. Gdown, I think you already got it. What is Gdown? logger I'm importing because I will be logging the information, and get size. Like I also want to see the size of the file. That is why I need the get size from the utility for you can say functionality. Now let me import them. So here, the first thing I will prepare one class called data ingestion. See, this is the class called data ingestion, and this data ingestion, what it will take? It will take your data ingestion configuration, and the data ingestion configuration from where you will get? You'll get from configuration manager. Inside configuration manager, you have the data ingestion configuration. Okay, so it will take this configuration and it will take these are the value one by one. Okay, and you can access here. Okay, now here I will create the first function called download data. See guys, in this function, I haven't done anything. I have only written that code only I showed here inside my trials.ipynb. I was ingesting the data from my Google Drive, right? The way I showed you, the same thing I'm doing, but I have written as a function here. Okay, first of all, I am extracting the data URL from my configuration. Okay, because if you see, I've defined my config, and this config is coming from my configuration manager. And this is my source URL. After that, I'm preparing my download link. Then I'm creating the directories called data ingestion. Then I'm logging the information. Let's say directory is created. Then I'm downloading the data using this prefix URL and all. Then I'm logging like data has been downloaded to this particular folder. Okay, this is the simple Python function I have written with using the same gdown like package. Okay, I think you already got to know from my trials.ipynb file, right? Then let's say I have downloaded my data. Now what I need to do? I need to extract it. Okay, I need to extract it because it's a zip file. So this is another function I prepared. See, this is another function I have written called extract zip file. So basically, it will take this zip file and it will unzip it. Okay, using this zip file package. Okay, that's it. That's it, guys. And what is the unzip location? I think you already got to know. Here I have defined unzip location would be my data ingestion. Okay, this file. Now let me execute and show you like how it will work. Okay, now let me execute. And now what I need to do? I have already updated my component. I need to update my pipeline. Okay, now what will be the pipeline? Pipeline is nothing but the step you will be running the function. The first step I need to like call this download file. The second step I need to call the extract zip file. Okay, so that's why we call it as pipeline, because let's say if I call this function as the very first, like extract zip file, so it will throw me error like there is no zip file, right? So to run this extract zip file, first of all I need to run this file, this function, then I will be running this function. Okay, so that's why we call it pipeline, because I'm following the pipeline. After this one I'm running this one. Okay, so how we can define the pipeline? So that's how we can define the pipeline here. So first of all, I'm opening one try except block. Inside that I'm initializing my configuration manager, because if you see, this is my configuration manager, because I want to take this configuration data ingestion configuration. So here if you see, I'm calling this get data ingestion configuration, this method, and then I'm calling this one data ingestion class. If you see, this is my data ingestion class. And this will take what? This will take your data ingestion configuration, and the data ingestion configuration I'm getting, I'm passing it here. Then first of all, I'm calling download data, and second I'm calling extract zip file. Okay, first of all it will download the data, and second it will extract the zip file. Okay, then I'm if any exception is there, I'm raising the exception. That's it. Now let me execute and show you whether everything is working fine or not. Now let me execute it. See guys, it has started downloading my data. Now left hand side you can see it has created one folder called artifacts. Okay, the way I have defined artifacts, inside artifacts one folder has been created called data ingestion. See, data ingestion has been also created. Now inside that it is downloading the data as data.zip. Okay, see, still it is downloading. That's why you can see some dummy name. Once this execution is complete, you will see the zip file here. And once zip file has been downloaded, it will also extract the zip file, because I have also mentioned extract the zip file. Okay, this is the function I'm running, if you see. So it will extract the zip file and save it inside my data ingestion. Okay, now let's wait. And when it is done, I will show you. So guys, you can see execution is done. Now let's see whether it has done or not. Now see guys, it has downloaded the data.zip file, and after unzipping, see, this is my data. This is my kidney CT scan image. I think you know this is the folder we have created. Inside that I have my normal image and I have my tumor image. Okay, that means my data ingestion is working fine. There is no issue with that. And we have seen the notebook experiment, like how we can perform this data ingestion. Now what I will do, I will try to convert it as our modular coding, because we have created the like module wise here, everything like where you need to keep these are the thing. Okay, and now I think you are already familiar with like what is config, then what is this entity, okay, what is configuration manager. These are the thing I think is clear. Okay, now like how we are organizing our entire code. So guys, so first of all, what I will do, I will copy this entity. Okay, I will copy this entity, entire entity, because as you can see in the readme I mentioned, first of all I need to update my config we have already updated. I don't need to update. I need to update my entity. Okay, now let me open my entity folder. Entity. Yeah, this is my entity. This is my entity. So inside entity folder, I will create one file called config entity. Config underscore entity. Config underscore entity dot py. Okay. So here I'll paste this particular code I have copied from my notebook. See, once you have done the notebook experiment, on same code you just need to copy paste inside your component. That's it. Now this is my entity. Okay. Now I need to upgrade. Now I need to upgrade my configuration manager in src config. Now let's open this configuration.py inside config folder. Okay. Now here I'll copy this import because this is my configuration related code. I'll open this configuration.py. I'll paste it here, as well as I will also copy this entire class I have written here, and I'll paste it inside that. Fine. Anything is missing? Okay. I also need to import this data ingestion config from my entity. So let me write from CNN classifier dot entity, because if you see it's present inside my entity, right? Config entity inside it's present here. So that's why I need to import from here dot config entity, import this data ingestion config. Fine. I think everything is fine. Nothing is missing. Okay. Now we also prepared our configuration manager. Now I need to update my component. Now let me go back to my component folder, and here let me create one file called data ingestion, because this is my data ingestion component. That is why I need to create the data ingestion.py. Right. Now here I will copy paste the same code. Again, I will copy this import, and I will open this data ingestion.py. I'll paste it here. Then I'll also copy this class, and I will paste it here. That's it. Anything is missing? Okay, I need to import again this data ingestion config. So what I can do, I can copy this import from here only, and I will mention it here. Okay, I hope everything is fine. Yes, now it is also done. Now what I need to upgrade, let me show you. I need to upgrade my pipeline. So now what I will do, I will open this pipeline folder, and inside that I will be creating one file. Inside that I'll be creating one file called 01, or let's write it stage 01, because this is my first stage, right? And it is nothing but my data ingestion. That's how we'll be arranging our pipeline. First of all, data ingestion will run, then your like model preparation, these are the thing, whatever you will be adding one by one you need to execute. Okay, that's why we prepared this pipeline. So the first component is my data ingestion dot py. Fine. So inside this one, first of all you need to import what, because if you see this is my pipeline. So to execute the pipeline, first of all I need to import this configuration manager from this one, my configuration.py, because it is present here, right? Let me import it. So stage 1. So I'll just write from CNN classifier, dot config dot configuration, and I need to import this configuration manager class. That's it. Then I need to import what, if I show you my notebook, I need to import also this data ingestion class, okay, from my component. So let me also import it. So it is present inside my component data ingestion. Okay, this is the component. Now let me also import it from CNN classifier dot component dot data ingestion, import my data ingestion class. Okay. Now I also need to import logger. So from CNN classifier, import logger. Fine. So here, first of all, I will initialize my stage name. Okay, stage name is nothing but our data ingestion. Okay. Then here, first of all, I will be creating one class called data ingestion pipeline. Data ingestion pipeline, and inside that I have created one constructor, and I'm doing pass because I'm not doing anything here. Okay. And there I'll be creating one method called main, def main. Okay. and inside that I will copy paste my this pipeline. Okay, that's it. So basically it will execute this pipeline here. Okay, now what I need to do, I also need to call this thing inside my main function. I think you know this thing actually in Python, why we define it, like if underscore underscore name underscore underscore, then underscore underscore main underscore underscore. So here Python will start reading from here only. So here first of all I'm doing what, I'm just logging the information like this stage has started. That means my data ingestion state has been started. Then I'm initializing my data ingestion pipeline, training pipeline. Then I'm just calling this main method. Okay, I'm calling this main method. If you call this main method, this pipeline will start. Okay, it will start ingesting the data. Then once I have done the data ingestion, I will just tell it like this stage has been completed. I'm just logging the information, and if anything is issue with my code, I'm just raising the exception. That's it. Okay, now this is ready. Now what I need to do, now if I go to my readme, I need to update my main.py. Now let me open the main.py. I think, yeah, this is my main.py. So here let me remove this code. So here first of all I need to import my data ingestion training pipeline and my logger. Okay, so that's how we can import, like final first of all I'm importing my logger, and from this CNN pipeline I'm importing this data ingestion training pipeline. Okay, this thing, if I show you pipeline, this file name data ingestion 1 stage 01 data ingestion, then I'm importing my data ingestion pipeline. Okay, once it is done, so once it is done, here I will come back to my pipeline. I'll copy the same code and I will just write it here. So here what I'm writing, I'm just initializing this class and I'm calling the main. Okay, main method, this main method, because the main has all the pipeline. And yes, I'm raising the exception. Okay, I'm logging the information. That's it. Now guys, my main file is ready and this is my endpoint as of now. And then whenever I'll integrate DVC and app, I'll show you how we can do it. But as of now, it is my main endpoint. Okay, now let me execute and show you how it will work. So first of all, let me save all the file. Yeah. Now what I will do, I'll go back to my project folder. I'll remove this artifacts folder. Okay, then I will execute my code. So let me open my terminal. Let me zoom and I'll just write Python main.py. Now see guys, it will start my data ingestion. See, it's downloading the data. See guys, so I think you got it, like how we can perform this notebook experiment, and after doing that, how we can convert everything as our modular coding by doing just copy paste operation. Okay, the same thing will be copy pasting from my notebook only, but we are organizing the code guys. The way we are organizing the code, it completely amazing. Okay, so here you don't need to change anything here. Like later on, let's say if you want to upgrade anything, just open up this config file and update. That's it. Everything it will reflect in your every code, right? So that's how actually we can do the code management and we can follow our modular coding. Okay, we can follow this like end-to-end implementation. So I hope you got it. Now see guys, it's running. So after running, I'll show you like all the things has been happened inside my artifacts. So guys, if you see execution is done, it is also printing the log like data ingestion completed. Now let me check it. So I'll go to my artifacts and see guys, it has ingested the data and also unzipped the data. Okay, that means everything is working fine. And if you want to see the running logs as well, you can also see the logs, like what are the files it has run and created the folder, everything it has logged the information. Now what I will do, I'll quickly commit the changes. But before that, I think you remember we downloaded one zip file in my resource folder. I'll remove this because this thing is not needed. Okay, now if I click on source control, now see it will do the commit operation. And make sure inside this .git ignore you have added this artifacts folder name, because I don't want to push my artifacts. Let's say this data I don't want to push in my GitHub. Okay, that's why I need to ignore this artifacts folder. That's why I've added inside artifacts, like whatever file present inside artifacts, just ignore everything this code represents. Okay, this star represents. I will I have already added in my .git ignore. Now what I will do, I'll quickly commit the changes. So let me just write the commit message, data ingestion added, and I'll push the changes. And if it is not working for you, so you can also do it from your terminal, like let's say git add, then git commit, okay, then git push. I think I already showed you, right? So it's done. Now let me go, show you. I'll go back to my GitHub repository and let me refresh. See guys, data ingestion added. Okay, so guys, now let's start with our next component, which is nothing but prepare based model. So what is prepare based model? If you have already worked with like image classification problem, I think you are already familiar with some of the pre-trained model. Okay, let me show you. If you just search like Keras application in Google, so here are some model. Okay, here are some classification model you can see. Like let's say you have exception, VGG16, VGG19, ResNet 15, and so on. Okay, so these are the pre-trained models are available. So what I will do actually, I will try to download one model from here. Okay, I'll try to download one model from here and I'll try to save it. I'll try to save it with my custom layer. So that what will happen, in this component actually I will save my model, and in my next component, whenever I'll be doing the training, I will just load the model and I will start my training. Okay, so that is the convenience to download the model from the Keras application itself. So that's why I named this component as prepare base model. Basically here I try to prepare my base model, okay, with my custom layer. And what is custom layer, guys? See here what I'm trying to do here. Let me show you in my Blackboard. So first of all, what I will do, I will take this VG16 architecture. So basically here the model I'm going to use, which is nothing but VG16. You can also use any other model. It's completely fine. So here I will take one image. So let's say this is my VG16 layer. It has 16 layer. Now I'll open my Blackboard and I will paste this here. So see guys, what I'm doing here. So I think you know what is transfer learning, okay, in computer vision. Okay, what is transfer learning in computer vision? So basically here, this is my convolutional layer. So let me take a new color. So if you see, this is my convolutional layer. Okay, so this is my convolutional, we call it our convolutional layer, conv layer, right? And this layer is already trained. Okay, this layer is already trained. So the weight actually you can see inside it is already trained. Even it is also trained. Okay, we call it as our fully corrected layer. That means FC layer. Okay, FC layer. So here we are using our basic CNN, and here we are using our CNN. That means convolutional neural network. So these two kinds of neural network we are combining together, and we are trying to create this architecture. Okay, complete architecture, and we are naming it as VG16. Okay, VG16, and it is already trained on ImageNet dataset. Okay, it is already trained on ImageNet data, right? I think you are already know these are the thing. I don't need to explain. So here, what I'm trying to do here, I'll try to download this complete VG16 architecture at the very first. I'll try to download this pre-trained model, and from here I'll try to extract this part. Actually, I will extract this part. Okay, I'll extract this conv layer. Then on top of that, I will add my custom FC layer. I'll add my custom FC layer, because this FC layer, if you see, it has like three layer, and it has like more neurons. Okay, they are using more neurons inside that. So I don't want to take these neurons. So I will just remove this part, and I will add my custom layer here. My custom layer. Let's say I will add one more layer here, and which would be nothing but my last layer. And here the number of class actually I'm using. So let's say in this case I have 2 class only. So I'll be adding 2 neurons here at the very last. Okay. So guys, how this architecture will look like? Let's say this is my first dense layer. This is my first dense layer, and at the last I have taken two layer only, because I have 2 classes. Now I'll connect this one, and here I'm going to take softmax activation function. Okay, then I will be able to classify, because it will give you some probability value, and whichever having like more probability, I will classify that object as my prediction. Okay, so yes guys, this is the complete agenda. So now let's do it. First of all, I will try to download this VG16. Okay, then I'll try to remove this part. I don't want it. And here this layer, actually I will do the freeze operation, because I don't want to train inside this layer. Only I'll be training like at my last layer, which is nothing but my FC layer. Okay, and FC layer will have only one layer, and it will have this 2 neurons. Okay, with the softmax activation function. Okay, now let me go back to my code. So here again I will create another notebook file called 02 prepare underscore base model dot ipynb. And also let me remove these are the thing. Okay, so at the very first, what I need to do, I need to upgrade my config.yaml. So let me update my config.yaml. So here I already prepared my prepare base model configuration. So let me just open this config.yaml and let me paste it here. see guys, this is your prepare base model related configuration. So basically what it will do here, inside artifacts, it will create another folder called prepare base model. And inside that, first of all, the base model I'll be downloading, okay, called VG16 from this Keras application. Okay, here, this VG16. So this model would be downloaded and I will be saving this model as h5 format. Okay, base model underscore h, the base underscore model dot h5. So it would be saved inside my prepare base model folder. Okay, then after downloading that one, I will do some modification this model. Okay, I will do some modification. What kinds of modification? I think you already saw in my Blackboard. Here I will picking up this conv layer, and on top of that I will add my own custom layer, own custom FC layer. Okay, and I will also assign the class, like we are having two classes here, and I will also add the softmax activation function. Then after that I will save the entire model and I will call that full model. Okay, full model, and I will save that model as well. Okay, so both model I will be saving here, and this full model actually I'll be using during my training. Okay, now here, that is why I've written here prepare base model. Inside that, here I have given another name called base underscore model updated. Okay, because this is my base model, BG16 model, and on top of that I'm doing some custom modification. That's why I'm just given base underscore model updated dot h5. Okay, so this is the simple configuration I've created. Now let me open my prepare base model IPynb file. So here the same thing I need to do. I will follow this notebook, and I first of all need to import my OS, because I need to go back one folder. Okay, I need to go back to my project folder. That is why I need to do it. Let me select the kernel and let me execute. Then again, if I do pwd, you will see I'm inside this resource folder. Actually, I'm inside resource folder. Now I need to go back. I'll execute this sort of code. Then if I again execute pwd, if you see, I'm inside my project folder, which is nothing but my kidney disease classification deep learning project. Now what I need to do, I need to prepare my entity, because if you see here, I need to prepare my entity. But before that, I also need to upgrade my parameters, because now I'm initializing my model. Okay, I also need to upgrade my parameter with that. So I'll open this params.yaml. And here I already assigned some of the model related parameter or training related parameter here. Let me show you. See guys, so augmentation is equal to true. I want to perform runtime augmentation. That is why I have given augmentation is equal to true. Image size I am defining. So image size is nothing but I mean this VG16. Okay, this VG16, if I show you this website, if you just see the documentation, input shape, it will take 224, 3. So this should be your input size. So that is what I am mentioning in my code here. If you see here, 224, 3 as per the VG16 model. Okay, it will vary as per the model you will be choosing. Let's say you are taking ResNet 50 or let's say Inception V3. At a time, this size may vary. Okay, you need to check the documentation and need to assign this parameter here. Now batch size I have given 16 because I'll be doing local training. That's why I have given like very smaller batch size. Then include top is equal to false. Why I have given include top is equal to false? Because if you see here, I don't want to include this top, okay, this layer in my you can say fully model. Okay, I will remove this model. So that is why I am only taking this conv layer. Okay, that's why I'm telling include top is equal to false. I don't want this part. Okay, so that is why I have given this parameter here. Now epochs I have just assigned 1 because I will be doing only one epochs training, because here it will take time. Okay, but for your case, you can increase the epoch size, at least start with 200 or 300. Okay, and try to see the model performance. Classes is equal to true because I have two classes only. Here we have this kidney tumor and we have this normal kidney. Okay, and weight is equal to ImageNet because whenever I will be downloading that VG16 model, I am also telling weight is equal to ImageNet because I want the pre-trained model and which is trained on ImageNet dataset. And learning rate I have defined as 0.01. Whenever I will define my optimizer, at the time I need the learning rate. So I hope guys you are clear with these are the parameters. Okay, and now let's use this parameter in my code. So what I will do now, first of all, I will assign my entity. Okay, I created the entity here. Let me show you. Just see guys, as per your data ingestion, we have create another class called data prepare base model configuration. Okay, and inside that I have again assigned all the parameter you can see inside my parameters and also inside my config.yaml. If you see here, root directory base model, updated base model. If I show you, root directory base model, updated base model, and params like image size, then learning rate, include top, weight, classes. Okay, everything you can see inside my parameters I have also defined here, and I have created this complete prepare base model entity. Okay, and why frozen is equal to true because I don't want to add anything else here. That's why I'm telling frozen equal to true. Let's say if user is adding something here, it will throw error. Okay, it won't be accepting anything else here. Now let me execute quickly. Okay. Now again, I will follow the same notebook and I will import this for my configuration. Okay, because if you see, next thing I need to update my configuration manager. So I need these are the import. Now I already prepared one class. First of all, let me copy this class. Configuration manager, and this was my data ingestion related configuration. Now I need to prepare for my prepare base model configuration. Now I already defined. See guys, I'm showing you quickly because I think you got the idea how I'm doing the things actually. See guys, I'm following the same technique what we did our previous component. Okay, the same thing we are doing, only this some of the parameter is changing here. Okay, now if you see here, whatever things I have defined inside my configuration, I am returning it here, here, and I also define this is the return type of this method. Okay, and I'm returning here. So yes guys, this is done. Now let me execute. Now what I need to do, I need to upgrade my component. Okay, now let me write my component. So here, first of all, I need to upgrade some libraries. So I need this request URL leave. Okay, these are the thing. And I'm also importing TensorFlow, as you can see here, because from the TensorFlow itself, I'll be downloading the VG16 model. It's done. Now I will define one class called prepare base model. So this is the class, and this class will take prepare base model configuration, which is nothing but this configuration. Now inside that, I will define some of the method. So the first method I'm going to define, basically it will download the VG16 model from the Keras application. See guys, here I have named this one get base model, and here I'm initializing tf.keras application VG. I want the VG16 model, and I'm also providing the parameter. Let's say input shape. Yeah, so where I'm getting the input shape, I'm getting from parameters. As you can see, this is the input shape. Okay, I have defined. And if you see here how to import or how to download the VG16 model, they have already given the code. You also need to define the input shape. Okay, then include top is equal to false, weight is equal to ImageNet. Okay, these are number of classes because it's giving 1000 classes because this is the pre-10 model and ImageNet has 1000 classes. Okay, but for me, I have 2 classes only. I need to rectify it. So guys, now if I show you my code, and I think now you are able to understand. Okay, I have given all the parameter one by one. Now once I have downloaded this model, I'm also saving this model. As you can see, I'm calling this save model, but save model function we haven't defined, so I need to define the save model function here. So this is going to be my static function. So guys, this is the static function I have defined, save model. Basically it will take the model and it will do the model.save operation. That's it. Okay, now what I will do, I have downloaded my VG16 model. Now on top of that, I also need to do some modification. I need to add my last layer, okay, with my number of classes and activation function as well. So this is another function I prepared here. Let me show you. See guys, this is another static method I have prepared called a prepare full base model. And see guys, it will take the number of classes, freeze all, freeze still, learning rate. These are the parameter. And if it is freeze all, let's say if you want to freeze all the layer, let me show you my blackboard. If you want to freeze all the layer, it will give freeze equal to true. So it will freeze all the layer. It won't be training. These are the layer actually at the time. Okay. But if you mention freeze still, like how many layer you want to freeze, let's say I want to freeze only 6 layers. So it will count 1, 2, 3, 4, 5, 6. Till 6 layer, it will do the freeze operation. It will freeze, and rest of the part actually, it won't be freezing. It will. So weight would be upgraded during training. Okay. In this layer also. So these 2 kinds of functionality I have also added in this code. But we always follow the freeze all technique because we always freeze these are the layer, and we just only change our last layer, okay, which is nothing but my dense layer. And this is my learning rate, because if you see here, I'm also using optimizer, and optimizer needs the learning rate. Now guys, this code actually I'm writing, if freeze all, then just freeze everything, otherwise freeze still. Okay, what like how many layers user want to freeze, you just freeze till that point only. Now if you see, I'm doing the flatten operation. After that, I'm creating my custom dense layer. Okay, and in the custom dense layer, I'm providing my number of classes I have, and at the last layer, I'm using activation function, and this is functional architecture. Okay, now once it is done, this is my full model. Okay, I'm compile my model. Okay, with my loss and accuracy, as you can see, I'm using categorical cross entropy loss, and at the end, what I'm doing, I'm returning my full model. And this full model, I need to also save it. So again, I have prepared another function here. Let me show you, called update base model. Okay, so guys, what this function is doing, this function here inside the function, actually I'm calling my prepare base full model. I'm giving all the parameter one by one. Okay, then at the end I'm saving my model inside my prepare base model folder inside artifacts. That's it guys. Now let me execute the code. Now this thing is also done. Then I need to upgrade my pipeline. Now let's me update my pipeline. So I already told you pipeline is nothing but it's just a step of running function. As you can see, I'm initializing my configuration manager. From configuration manager, I'm calling this prepare base model config. As you can see, prepare base model config, this configuration. Then this is what I'm passing inside my prepare base model class. And first of all, I'm calling get base model. This method get base model, it will download the base 16 model. Then after that, I'm calling my update base model, which is nothing but this function. This function will update the base model and it will save inside the folder. Now let me show you guys. If I execute the code, see, model has been downloaded and it is also saved inside my folder. Now let me open the artifacts, and inside artifacts you can see prepare base model has been created. Now inside that you can see two model. So this is my VG16 base model. Okay, the model I have downloaded, and this is the updated model. Okay, I will be using during my training. So guys, yeah, I hope this thing is clear. Now it is working fine here. Everything is fine. Now let's try to convert this thing as our modular coding. So again, I will follow the same technique to convert this thing as our modular coding. First of all, let me remove these are the thing. I also don't need the parameter. So the first thing, I need to upgrade my entity. So let me quickly open my config entity, and here I will copy this entity as it is, and I will update it here. So guys, I'm going a little bit fast because I think you got it. What are things I'm doing? And after the entity, I also need to upgrade my configuration manager. So configuration.py, and here I'll copy this method get prepare base model config, and I will update after this get data ingestion config. That's it. Now I also need to import this prepare base model config from my entity. So here I can import it like that. Okay. So it is present inside my config entity. I think I already showed you. Now see everything I am. Now see guys, everything I am importing. Now everything is fine. Now after that, I need to upgrade my components. So again, I will go to my component folder, and here I'll create another component. So let me name it as prepare base model. Prepare underscore base underscore model dot py, and here I'll copy paste the same code. And anything else I need, let me just check it. Yes, I only need this path. If you see, I'm using path method actually, so I need to import it from path lib import path. Okay, I also need to import this prepare base model from my config entity. So from CNN classifier dot entity dot config entity, and I need to import this prepare base model config. Okay, I think everything is fine now. Let me check. Okay, I need to also write import prepare base model config. Now I think everything is fine, guys. Now what I need to do? I need to upgrade my pipeline. So let me open my pipeline folder, and here I'll create another pipeline stays 02 underscore prepare underscore base underscore model dot py. So this is my pipeline, and I'll be following the same pipeline technique. So first of all, I will import my configuration manager and prepare base model class. I think you already saw how I was importing this thing. Okay, because I need this configuration manager and this prepare base model class. Both I'm importing here. Then I will give the stage name here, which is nothing but my prepare base model stage. And with that, I will also create one class called prepare base model training pipeline, and here again I'm initializing this constructor and I'm passing, and inside that I will be creating another method called def main. Fine, inside that I'll copy paste my pipeline. Fine, then I also need to call this one inside my main name method, main name function, okay, in Python. So it will execute the code from here. So again, I'm initializing my class and I'm calling this main method from here. Now this thing is done. Now I need to add this pipeline in my endpoint. So let me open my main.py. So here, first of all, I will import my prepare based model training pipeline on this pipeline itself. So that's how we can import. This is inside stage 0 to prepare based model, this prepare based model training pipeline. And here I'll initialize my prepare based model uh, training pipeline. So I'm initializing this one and I'm calling my main method. As you can see, main method, and I'm telling stage has started and stage has completed. And if exception is occurring, I'm giving exception, raise exception. That's it. Now let me check, guys, whether everything is working fine or not. So I'll open my folder. Again, I will remove this artifact and I will open my code and let me execute from scratch. So let me quickly run it. So Python main.py. I hope everything will work. So first of all, it will run the data ingestion, because if you see data ingestion pipeline, I'm running at the very first, which is nothing but this pipeline. Then I'm executing my prepare based model, which is nothing but my second pipeline. Okay, now if you see, it's running, it's downloading the data. So guys, as you can see, my pipeline has run successfully and it is telling prepare based model completed. Now, if I go to my logs, if you see, even it has also ingested my data. If I show you, in data ingestion has been also done. See, downloading data, and with respect to that also it has downloaded the model as well. Now, if I show you my artifacts, this is my data and this is my model. Okay, so that means everything is working fine. Now let me just quickly commit the changes. So I'll just write prepare base model, add it. It's done. Now let me verify. See guys, commit has been done. So yes guys, we have done this component. Now so guys, now let's start with our next component, which is nothing but training. So because I already prepared my base model and my base model is also ready and it is also upgraded. Now I can start my training. So again, what I will do, let me just close these are the thing. Okay, so inside resource folder, I will be creating another IPYNB file. I'll name it as 03 uh, model training. Dot IPYNB. So here again, I will copy paste the same code. I need to go back to my project folder. I'm just going a little bit fast because I think you get it what I'm doing. Yeah. Now the first thing, I need to prepare my entity. Okay, so I already prepared my entity, but before that, I think you saw I need to update my config.yaml. Now let me update my config.yaml file. So I prepared my configuration related my training. So guys, this is my configuration model training, and here it will create another folder inside artifacts called training. Inside that, it will save my trained model. Okay, as you can see, model .h5. So this is going to be my final model after training. So this model I'll be using for my prediction. Okay, and it will be saved inside training folder. Okay, this is the complete path I have assigned. Now what I will do, I'll quickly write my entity in my model training IPNB file. So guys, I already prepared the training configuration. See guys, this is my training config entity. So here again I'm returning these are the thing only, root directory and train model file path, root directory train model file path. With respect to that, I'm also giving my updated base model path. Basically this is the path of my updated base model. Okay, this one, updated base model path, this is the path. It is present inside artifacts slash prepare base model slash base model underscore model updated dot h5, this model. Okay, this model I'll be loading and I'll be training. Then my training data, where my training data is present, it is present inside my data ingestion. So this is the folder. Okay, here my training data is present, so I need to give these are the path. Okay, then now params, that means epochs. So where I'm getting the epochs, I'm getting from my params.yaml. This is my epochs. Okay, here then I'm giving batch size. If you see, batch size is here, batch size. Then I'm giving augmentation is equal to this one, because I want to do runtime augmentation, and image size. Okay, again I'm giving event size. So these are the configuration I have prepared here. This is my entity. Now what I need to do, I need to upgrade my configuration manager. So I'll again import these are the thing. With that, I also need to import my TensorFlow. So import TensorFlow as TF. Now let me execute. Done. Then again I will copy paste the same class I've created. Then inside that I will write my get model training related configuration. So this is my model training related configuration, guys. Okay, and here if you see, I'm giving all the paths. So basically, first of all, I'm giving my prepare base model. Okay, this path here, if I show you, it is coming from my configuration. So this is the prepare base model. Okay, this one, updated base model path. As you can see, this is my updated base model path I'm giving here, and I'm also initializing my training data path. Okay, which is nothing but this one, kidney CT scan image, and it is present inside my data ingestion. I'm getting my data ingestion, then unzip directory, then inside that I have this kidney CT scan. Okay, and this is my complete configuration I have prepared here. And here if you see, these are the things actually I'm returning, whatever things I have written inside my entity. And I've also assigned the return type, which is nothing but training config, and this training config I've created here. So yes guys, this is the simple code I have just only written. I'm just doing the configuration management here, nothing else. Now let me just quickly execute the code. Now what I will do, I will start with my component creation. As you can see, I need to start creating my component. So again, I will import some of the libraries, and I'll initialize my training training class, and again it will take this training configuration. Okay, and this configuration I will get from this configuration manager. Now the first method here I'll be defining called get base model. So this function will try to load the model from the artifact itself, the model you have saved. As you can see, this is the model it will load here. Okay, using keras.load model. Okay, it will load the model. Then after that, I will prepare another function called train valid generator. Basically, it will generate your training and validation data. Here, I'm not separately doing any train test speed. That is why I'll be using Keras already inbuilt this train val generator function. As you can see, I'm using this generator function. Okay, and I'm just creating my training dataset as well as my validation dataset. And here on top of that, I'm also doing some augmentation. Let's say I'm performing some scaling operation. Okay, then if you see here, some validation operation I'm doing, and here I also mentioned my validation speed is equal to 0.20. That means inside my training data I will have 80% data, inside my validation data I will have my 20% data. Okay, see, if you are not doing trend test split manually, it's completely fine. You can use this keras data generator to generate this trend test split for you. And this code I have copy pasted from the keras documentation. If you just go in the keras documentation and search for trend valid generator in keras, you will get this code. Just copy paste here only. That's it, guys. That's it. See, this is the simple code only. They are doing some runtime augmentation here. That's it. Now this function is also prepared. Now again I will define another function called save model, because after training my model I also need to save my model, right? So again I have created one static method called save model. So this will take the model and it will save the model. That's it. Now finally I'll create my training function. This is my training function, guys. So basically it will start the training. First of all, I'm calculating my step per epochs and validation step. Okay, I think you already know if you have already worked with image classification, because during training actually we try to pass these two parameter and we can calculate this formula. Okay, using this formula we just try to do the division, okay, with this batch size, okay, to our sample number of sample we have. Now I'm doing model dot fit. I'm giving my training generator data. I'm assigning my epochs, the number of step per epochs, okay, I got from here, and validation step, and also my valid generator, that means my valid data. Okay, then this line of code actually I don't need. I'm not using callbacks here. Okay, now guys, everything is fine. Once my model is trained, I'm saving my model here. That's it guys. Okay, now let me execute. It's just a simple model training I'm doing. Okay, I think you already know. Now I need to define my pipeline, so let me just define my pipeline here quickly. So I'll just write try, and inside that I'll mention my pipeline. I don't need this callbacks. Okay, I hope everything is fine, but I also need to import this configuration manager. Configuration manager I'm initializing here. If you see, this is my configuration manager. I'm getting this training configuration, and this training configuration I'm passing inside my training. Okay, then first of all I'm calling my get base model. Basically it will load the model. After that I'm calling this train valid generator. It will generate your training and validation data. Once data has been generated, I'm calling my training. As you can see, I'm calling my training, and it is taking this one. I don't want to give it. Let me just delete it. Let me execute. Yeah, I hope everything is fine. Now let me execute and see whether everything is fine or not, whether it is able to train my model or not. See guys, I think training has started and it is telling found this many of images. And see guys, training has started. I'm training just one epochs and this is training going on. And as you can see, your accuracy and losses. So let's wait. So guys, as you can see, training is done and this is my final metrics. So this is my loss. Loss is huge here because I only trained one epochs in this case. And this is my accuracy, only 56% accuracy I'm getting, and validation is 60. That means everything is fine, but I just only need to increase the number of epochs here. As you can see, I am only training one epochs, and using one epochs, this model can learn in a good way. At least you just need to go start with 200 or 300 epochs. You can do it. I'm just showing you quick training, okay? But whenever you're training your own model, just try to increase the epoch size here. So yes guys, this notebook is working fine and we are able to train the model. And if I show you my artifacts right now, so here I think it has created another folder called training. Inside that, this is my trained model. Now let's try to convert this code as our modular coding. So what I will do, first of all, let me save this file. And at the very first, I need to upgrade my entity. So let me open this config entity and I will copy this code from here. This is my entity. Done. Then I'll remove and I will update my configuration manager. So I'll copy this method. I'll open this configuration.py and here I'll mention it. I also need to import this training config from my entity. Anything else I need to import here? Let me see. I think everything is fine. Okay. I need to also import OS, I think, operating system package. So let me import OS. Import OS. Now let me check this. Yeah, everything is fine. Now after that, I need to update my component. So let's go to my component. This is my component, and here I will create another component called model underscore training dot py. So here I'll copy paste the same code again. Let me check everything is fine or not. Everything is fine. Then finally I need to create my, okay, I need to import this training config, sorry. So from CNN classifier dot entity dot config entity, import this training config. Now anything else? I also need to import the path. Yeah, so from path lib, import this path. I think everything is fine right now. Then I will finally update my pipeline, I think. Yeah, pipeline I need to update. Now let me open my pipeline. And here I will create another pipeline called stage 03 underscore model training. So first of all, I need to import my configuration manager and my model trainer. Let me import them quickly. I'm not using callback, so callback I will remove. So these are the things actually I need to import. And I think it should be model training. Okay, because it is present inside my model training, as you can see, this class. Now this is I have updated. Now I also need to give this stage name or training. And here I'll initialize this method. First of all, I'll initialize one class called model training pipeline, and inside that I'll create one method def, or just let me write it, def main. Inside that I will call my pipeline. Yeah guys, I think everything is fine. Then I will call this one inside my if statement. That's my main function. Yeah, now same thing I will call inside my endpoint, which is nothing but my main.py. So first of all, I need to import my model training pipeline. It is present inside, I think, stage 03 model stage 03 model training. Okay, now finally I can write my training. Yeah, everything is fine. Now let me quickly test this code. So I'll open my folder, remove these artifacts again, and let me open my code and my terminal. Python main.py. See guys, it has started. Now let's wait. See guys, data downloaded done. Now model is also prepared. Now it is started the training. See guys, training is going on. Now let's wait. So guys, as you can see, training is completed and it is also training. Training is completed here. Now let me show you my artifacts. See guys, data downloaded, model prepared, training has also done, and this is my final model. So guys, we are successfully able to train the model. Now in the next component, I will do the evaluation stage. There I'll calculate my accuracy score. Okay, accuracy and losses. Basically, I want to see my model performance there. Then after that, I will create my prediction pipeline. Now what I will do, I will quickly just commit the changes. So model training added. Done. Now if I go back, so yeah guys, it has updated. So guys, now we'll be creating our last component, which is nothing but model evaluation. And now I will show you like how we can integrate MLflow with this project. Okay, and how we'll be actually tracking our experiment, and how we'll be like, you can say, register our model. So everything I will show you in this component only. So for this, actually what I will do, I'll create one IP1V file here called 04 um, model evaluation dot IP1V. Okay, so here the first thing I will connect my kernel. Okay, so guys, one particular things actually you need to know, because this is the prerequisite for this project. So first of all, you need to know like what is MLflow, okay, why you will be using MLflow and all. So for this, actually just visit Krishna XR channel, and if you click on the video, so here you will get one video called the power of MLflow and DAXUP open source data science project collaboration. Okay, just try to watch this video, so you will get the entire idea about MLflow. Okay, why we will be using MLflow, what is experiment tagging, what is model registration, and how we can connect MLflow with the DAXUP website. Okay, everything you will be learning from this video only. So that is why I'm not going to explain this thing again and again. So I'll directly start implementing the code. Okay, directly start writing our MLflow pipeline and all. So this is the prerequisite for this project. You just try to learn. So you just go ahead and try to watch this video. After that, you can come here and try to understand like whatever things actually I'm doing. Okay, so this is the prerequisite for this video. Now guys, let me go back to my code, and here first of all I will copy paste the same code. First of all, let me close these are the thing. Okay, so I'll copy from this notebook only this voice operation, because I need to change my directory. Then I will see the project working directory. Then finally I'll change my directory. Okay, done. Now the first thing what I need to do, I need to first of all collect the MLflow URI. Okay, MLflow URI. So where I can collect the MLflow URI. So for this, you need to visit like there is a website called DAXUP. Okay, daxup.com. So just logging with this website, and how to log in and all, everything you will get from this video. All the information has been given in this video. Now here, first of all, I need to connect my repository. Okay, the repository I am committing my code. Let's say this is my repository. Here I'm committing all of my code. Okay, so I have another repository, the same project. Okay, so this is public repository. That's why I'll be connecting this repository with this DAXUP. So here, first of all, I will click on create, and I will click on new repository. Then here it is telling create a blank repository or create from a template. And it is also telling like connect a repository. Okay, so what I will do, I will connect my repository, because my repository is already available in my GitHub. I'll just connect it. So I'll just click here, and it is telling just connect with GitHub. And if you have your repository inside Bitbucket or any other like platform, you can also connect, but I have in my GitHub, so I'll just connect. So make sure you have your code in your personal account. Okay, otherwise you won't be able to access this GitHub repo. So here basically I'm committing my code, but this account I can't access because this is a SAR account. So if I want to access the accounts, I need to use my personal account. That is why I just like replicated the same repository. Now I will be able to connect with my DAXUP. Now here, what I will do, I'll just click on this add revoke access repository. Just click here, and after that you need to select your account. So this is my account I will be selecting. Now it will ask for the, like you can say, password. So you just need to provide the password. I have already logged in, that's why it's not asking for the password. Now here you just select the only selected repository. Now just select the repository you want to connect. So this is the name of the repository. Let me just copy the name. Now I'll search it here. See guys, this is the repository. Now I'll select and I will just click on save. Now here I just need to select the repository I just connected right now. So let me just search with the name. So guys, this is the repository, my kidney disease classification. Now I'll just click on the repository, and here I just need to connect the repository. See, once I have connected, so you will be able to see like that. Now here, what I will do, I will just click on this remote. Okay, if I click on the remote, here you will see one option called experiment. Okay, just click on the experiment, and now see guys, it will provide this MLflow UI. Okay, MLflow UI basically, MLflow supports this DAXUP. So using DAXUP, actually you can launch this MLflow server here. Okay, so basically that's why we are using DAXUP. Now to connect this MLflow, I need this MLflow URI tracking. Okay, so this tracking URI I need actually. So I'll just first of all copy this URI. Then I will also launch my MLflow UI here. See, you will be able to see the MLflow UI. And it would be completely empty at the very first. There is no experiment exist. So now what I will do, I will go back to my code. I'll go back to my code, and here I will just paste this credential, or what I can do, I'll open my readme. I can update my readme later on. Let me just keep it here. Now quickly I'll just add these are the credential in my environment. Okay, so I already have my previous environment. Let me just change it. I'll just take a code cell. See guys, here you just need to add these are the tracking URI, then username and tracking password in your environment. Okay, using wes.environment you can do it. Now let me do it quickly. So, and don't share this credential with anyone, otherwise they will also able to access. I will just delete my repository after the recording. That's why I'm showing you here. So first of all, what I will do, I will copy this URI, and I will change with this URI, and username would be username, and this my username, and this the password, and I will replace the password here. Okay, yeah, I hope everything is fine. Now what I can do, I'll also update in my readme. So let me just open my readme. So readme.md. So here just let me update. So here I will replace with this credential. I have already provided all the link and all. Now I also need to change this URI. Yeah. I hope everything is fine. Now if you just open it with this open preview, you will able to see how I upgraded the things. Okay, so guys, I already given the MLflow documentation link and Hub link, even this tracking URI, and how to export this. Also I'll show you like how you need to also export this in your terminal. Okay, that's why this command you need to run. So everything I have just given here. So now what I will do, I will quickly just copy paste this command. See, this command actually I'll be copy pasting, export MLflow tracking URI, and I will open my terminal. You also need to execute in your terminal. Okay, otherwise it won't be working. So here I need to export in my terminal. So basically it will export this tracking URI in your environment variable automatically. Okay, and in the Jupyter notebook I have added, that is for the Jupyter notebook only. Now I'll again run the second one, then I will run the third one. Let me just copy the password again and replace it here. And I'll copy and execute in my terminal. That's it guys. Okay, so once it is done, I think I have already updated my readme and all. So for your reference, you can refer it later on. Now I'll close this readme and let's go back to our notebook. Okay, now I can delete this cell. All right, so I'll just execute this particular code here. Okay, now it will set these are the credential in my environment variable. Now what I will do, and I can name this file as model evaluation with MLflow, because we are also integrating MLflow with that. Okay, so I'll name it like that. Now I can again select the kernel and let me run from again. Okay, everything is fine. Now what I will do, I will import my TensorFlow. Now here, the first thing what I need to do, I need to load my model. So where is my model? My model is present inside artifacts, inside the training folder. Okay, so let me first of all load the model. So here I have loaded my model. So let me execute. Then after that, I need to initialize my this one. If I show you my README, my entity. Okay, I need to initialize my entity. So let's also define my entity. So model evaluation config. So guys, this is the entity. So this is my path of the model. So here I need to provide the path of the model. Then training data. So what is your training data? Training data should be present inside data ingestion, because I also want to pick the data to do the evaluation purpose. Okay, basically I will be doing the evaluation test and I will check my model performance. Okay, that is why. Then all parameters. as a dictionary I'm taking, because basically this is the parameter file I have called params.yaml. So all the like parameter I'm taking as a dictionary here. I'll show you like how we can store it here. Then MLflow URI. Okay, I also need MLflow URI. So this URI I need to also add. Then params image size, okay, and bash size. I think it is available inside params.yaml. Now guys, what I will do, I will quickly execute this code. And here again I will import, these are the libraries because it is needed for my model evaluation configuration. Okay, then finally I will create my configuration manager, and with that I will create one method called get data evaluation configuration. Just let me show you. See guys, now here I'll just change this tracking URI. I'll copy and I'll just change this tracking URI here. Okay, I think everything is fine. Okay, everything will remain same. And see guys, here what I'm doing, I'm providing all the path, like my model file path. It is artifact slash training slash model.h5. Then training data, it is present inside my data ingestion kidney CT scan image. If I show you, it is present inside data ingestion kidney CT scan image. And this is my MLflow tracking URI. And all parameters I'm getting, see here, I'm reading all the parameters and I'm storing inside params. And this params I'm returning here. Okay, all params, because whenever I'll be using experiment tracking using MLflow, I need to log all the parameter there. Okay, now this is my image size and bash size, and once it is done, I'm returning my configuration. Now let me execute. Now I will start creating my components. So for this I need some libraries, so let me import them. Then I will create one class called model evaluation, and it will take this model evaluation configuration, this method. Then after that I will again create this train file generator. I think you remember we created this thing in our data model trainer. See, this train file generator I will be again creating, because again it will separate out my testing data. Okay, and using Keras you can do, you just search on Google, from the Keras website you will get this code. Okay, valid generator, this function I will be using. So again what it will do, it will like pick up my data, entire data set, and from the data set it will prepare the testing data for me. Okay, prepare the testing data for me. And what is the testing size? It would be 30% data will be taking for the testing purpose. Okay, and it is loading as using data generator, and this is the directory I'm giving. What is the directory guys? This is the directory. Okay, this, from this directory it will load the data. So yeah, it is done. Let me execute it again. Yeah, then again here I'll be creating another static method called load model, because I also need to load my model, the model I have present inside my training. I need to load the model. And why I've given a static method, so whenever you are defining this static decorator, that means this function won't be taking any kinds of self, because if you see here it's taking self, it's a class function, but this function is an independent function. I can access it from anywhere. That's why this I have written static function. If you know object oriented programming in Python, I think this concept would be clear. Now once my model is loaded, I also need to evaluate the model. And to evaluate the model, here I have written another function called evaluate. So in the evaluate, what it will do, it will just load the model using this load model function. Then it will generate the valid dataset. That means your test dataset it will generate. Then after that, it will do the model evaluation and it will take your valid generator. That means this data, and it will return you some score. Okay. And now what I need to do, I also need to save the score. Okay. So to save the score, there is another function I prepared called save score. Now here, if you see save score, and I'm just storing this score one by one. So the first one is your loss, and the second one is the accuracy score. Okay, and I'm saving as a save JSON. Okay, JSON score.json format I'm saving. And if you see save JSON, I'm importing from my utility here. Okay, save JSON I'm importing from here. So once it is done, that means I'm able to successfully save my metrics. Now what I need to do, and now what I need to do, I think if you have watched that particular lecture of the MLflow, I think you already got to know like what is experiment tracking. Okay, in MLflow, why we do experiment tracking there. Okay, everything I think you got the idea. And what is model registration also, I think you got the idea. Now you need to write the MLflow code here, and it is like very simple. So here, let me show you. See guys, this is the MLflow code. I think you have seen from the particular video. Let me just yeah. Yeah, I think you have already seen from the particular video. So basically here we need to define one function called log into MLflow. And here I just need to set the registered URI. Okay, and what is the URI? My MLflow URI. The URI I have defined here. So basically it will track the information in this URI. And this URI is running my server. This is the MLflow server is running. So that is why I'm providing the URI here. So all the experiment you are tracking, just try to track in this URI. That is why I'm setting this URI. Once it is done, your MLflow dot start run will start. Basically your MLflow will start tracking the experiment. Then first of all, I will log the parameters. While I'm getting the parameters is present inside my config, and from the config itself I'm returning, if you see here, all parameters. Okay, all parameter I'm returning, and here I'm initializing my configuration. Okay, so basically first of all it will log here all the parameter. So once all the parameter has been logged, I also need to log my metrics, right? So again I'm calling MLflow.log metrics, and here I'm logging my metrics. First of all I'm logging my loss and logging my accuracy score. Then once it is done, so here one condition is there: if tracking URL underscore type store is not equal to file, track everything in my URI I have mentioned, otherwise track everything in my local system. Okay, so what is this meaning? I think you already know from the video itself. Okay, so everything has been explained in that video. Just try to go watch that video, then you will be able to understand this complete MLflow like part. Okay, otherwise there would be some confusion in your mind. That's why I'm telling, just go ahead and watch that particular lecture. You will get the idea about MLflow. Okay, what we are doing exactly here. So once it is done, we are done with our model evaluation. Even we have also done with our MLflow integration with my project. Okay, now let me execute this project quickly. Now at the last I will initialize my pipeline. So let me just show you my pipeline. See guys, this is my pipeline. I'm initializing my model configuration manager. Then I'm getting my model evaluation config. This thing I'm passing inside my evaluation. And first of all I'm calling this evaluation. Okay, evaluation function, it will do the evaluation. Then after that I'm logging the experiment to my MLflow. Okay, this function. Now let me execute and show you. See guys, first of all it will prepare the testing data, and it will predict on top of the test data. Then it will calculate the loss and accuracy score. That score it will be saved in your local, then it would be tracked inside your MLflow server. See guys, I think metrics has been generated. I think there would be a metrics file we'll be getting. I think somewhere this metrics file would be there. Score.json. Now see guys, I think it is trying to push all the experiment to my MLflow server. Even it is also pushing the model to the MLflow server. See guys, execution is done, and it is telling created version 1 model VG16 model. Okay, because the name we have given here VG16 model. So basically it has already tracked in my MLflow. Now here you'll see one metrics would be generated, I think. So guys, it is not saving the score because I haven't called this save score method. So I need to call it here basically. So let me just call it. So here if I just write self dot save score, I think now it should save the score. Now you can try it. I think it will save the score. Now let me go back to my MLflow, and here if I refresh, now we'll able to see the experiment. See guys, this is my first experiment, and I have just done it 7 minutes ago because I just paused the video for some work. That's why it's showing 7 minutes. Now this is my model. It is also registered my model, as you can see, VG16 model, and this is my source. Okay, if you see the path, complete path, this is my location of the model, like where it is present. So this is present inside my artifacts inside this training file. Okay, so this is the location, and this is the name. Like it will generate some random name. I think you already saw from the video. Now if you want to see all the parameter it has tracked, now click on the experiment. See guys, this is the complete source, and this is my username, and this is the date and time. And see guys, it has also tracked my model. So model has been also registered. I will show you the model, and this is the metrics guys. As you can see, this is the accuracy 61%, and this is the losses. Okay, I got here. And with respect to that, this is the parameter it has tracked. See, all the parameter I have mentioned inside my params.yaml. So everything it has tracked. Okay, everything is that it has tracked. And with respect to the parameter, this is my accuracy and losses. And you can also add some description, but description I haven't added here. Okay, so these are the thing. Now let's say I want to do another experiment. Okay, I want to do another experiment. This let's say this parameter I have assigned. Let me just show you. This parameter I have assigned, it is not giving me good, because see, so here guys, if you see the here learning rate should be hyperparameter. Okay, then epoch should be hyperparameter. Okay, then batch size should be hyperparameter, augmentation should be hyperparameter. So this parameter you can change and you can try different experiment. Okay, so we call it as experiment tracking. So instead of doing our hyperparameter tuning manually, if we are using this kinds of MLflow, so it would be very much easy for us to do it. And let me show you the model registration, guys. So just click on the model and see, this is the model PG16 model, and this is the version of one of the model. Okay, this is the first version of my model. So you can also like push this model to the staging area or production area. Staging area means this is the testing area. First of all, you will be doing the testing of your model. If your model is working fine, then you will be moving that model to the production area. Okay, so that way you can do. And how to do it, just click on the version, and here you will get one parameter. See, stage is equal to none. You can just give to staging. Let's say I will give this model to the staging area. Click on OK. Now if I go back, now see guys, it's this model is running in my staging area. You can also give to the production area. Okay, you can also do it. Now let me go back. See, it's running on the staging area. Now it will also track the model. Now let me show you the different experiments. What I will do, I will come here and let's change the learning rate. Let's say I will give 0.2. And now you can also make it as false. Okay, I'm not making it because again it will take time. So only I'm just changing learning rate is equal to 0.02. Now what I will do, I will just I'll just open my terminal, and here I will again execute the code. Okay, I haven't added the entire pipeline, so that is why. So I need to run from my notebook. So what I will do, I will again run from scratch. I will first of all restart the runtime. Then let me execute one by one. Now guys, it has saved that JSON. Okay, score.json. Now if you see, this is the score.json you have, this is the loss, and this is the accuracy score you got here. Okay, so I think it's working now. Now let's wait for the MLflow tracking. So guys, now if you see, it has created version 2 of the model. Okay, version 2 of the model has been created. Now let me go back and let me just go to my MLflow, and you can refresh the page here. See guys, okay, this is my last experiment I have done. Okay, only 2 minutes ago, and this is the second version of the model. Now again, let me open this model, and this is the parameter. I just changed the parameter here, learning rate 0.2. With respect to that, the accuracy score I am getting, this is the loss, and this is the accuracy score. Fine. Now you can compare the model also here, like which model is better here. Okay, which model is better here? So what I can do, I can try another. I can do another 2 more experiment. Okay, that would be good, I think, to show you the comparison. So what I will do, I will again open my parameter, and here what I will do now, augmentation is equal to, I'll just keep it as false. False. Okay. Now learning rate, let's change it to 0. Or let's say 0.8 I will give. Fine. Then yeah, batch size you can also change. Otherwise, everything you just keep it as default. Now what I will do, I will again execute my code. I'll come here. Now I'll first of all restart the runtime. Now let me execute them one by one. And guys, this thing how to perform for the machine learning like project, I think I have already explained. So just go with this video, okay, end-to-end MLOps data science project implementation. So here we have already like shown you like how we can perform using machine learning project, and this is for the deep learning project. Okay, what will be the like difference between machine learning and deep learning? You will get the idea. Now guys, if you see, it has tracked my version 3 of the model. Now let me go back and refresh. See guys, this is the version 3 of the model. Now let's compare all the model. I'll select all the models. See, just if you just click here, it will select all the model, and either you can delete it, either you can do the comparison. So let me do the comparison. So here I want to see parameter. I want to see all the parameter. Let's say I want to also see my image, batch, include top, epochs, classes, wait, all the parameter. With respect to, I want to see my metrics, accuracy score, and losses. Okay, now you can see this is my parallel coordinate plot. Okay, so from this plot itself, you can get the best model. Now guys, try to check it. My augmentation is equal to true. First of all, check the highest accuracy score you are getting. All the actually, I think accuracy are same. Okay, because there is no major changes has been done after changing the parameter. Because okay guys, that is my mistake actually. Actually, I'm just executing this model evaluation again and again, because let's say whenever I'm changing these are the parameter, okay, it will reflect in during the training, right? Because the current model I have, this is the first time model we train the model, right? So there is no changes in the model. That is why I'm getting again and again same metrics here. So that's my bad guys. So I'm extremely sorry for this. So what I will do, first of all, let me convert this code to our modular coding, then we'll try to run the entire pipeline again. Okay, then you will be able to see the changes. Now first of all, let me make it as 1. Okay, now let me go back to this model evaluation. First of all, let it finish. So I got my version 4 of the model. It's fine. Now let me just quickly convert this code around modular coding. Then I will run the entire pipeline, okay, which is nothing but my endpoint main.py. Then it will run all the pipeline one by one. Then it will reflect the changes. Okay. Now let me first of all do it quickly. First of all, I need to upgrade my um, entity. Let me close this at the tab. Okay. First of all, let me copy the entity from here. This is my entity. I'll copy and I will add it inside my config entity. Done. Then I also need to upgrade my configuration manager. So first of all, I need to import this SafeJSON inside configuration manager. So I need to import here SafeJSON, and with that I will also need to update this thing. I also need to update this model evaluation config here. Now I think everything is fine here. No change needed. Now quickly what I will do, I will update my components. I'll copy this code and again I will create one component here called model underscore evaluation underscore MLflow dot py. Then I will quickly copy this component as well. Now let me see anything is needed or not. Model evaluation config is needed. I'll just try to import it. So from CNN classifier dot entity dot config entity import this model evaluation config. Now I think I also need the model. So it's giving error because it should be self dot model. Okay, self dot model. Now I think everything is fine. And SafeJSON I also need here. So SafeJSON I can import from here, I think. Now let me see everything is fine or not. Mm, yeah, guys. So I think everything is fine here. Okay, I don't need to do anything else. Yes. And one change actually you need to do here, I forget to tell you. If you see here, whenever I'm trying to import MLflow, okay. So here I'm doing for deep learning project, and here I'm using Keras, okay, Keras library, TensorFlow Keras library, okay. So that is why if you see here, MLflow also support Keras. So that is why I'm also importing Keras from here. But previously, whenever I was doing for my machine learning project, I was importing scikit-learn here. Let's say you are doing project using PyTorch. At the time, you will call mlflow.pytorch. Okay, so that's how it supports all the library you have in deep learning, okay, or machine learning. So here I'm using Keras. That's why I'm importing Keras here. Now this Keras I'm using, okay, and this Keras I'm using here. If you see MLflow Keras log model, okay, you need to call this Keras. Otherwise, it won't be considered it's a deep learning project. Okay, and whenever you are using machine learning at the time, call mlflow.scikit-learn, sklearn. Whenever you are using PyTorch, just use MLflow PyTorch log model. Okay, that's how we need to change this thing. Here I'm using Keras, that's why I've mentioned Keras here. That is the only modification you need to do inside deep learning project, and everything will remain same. Now I think I have already upgraded my this MLflow component. Now what I need to, I will quickly update my pipeline. So let me go to the pipeline, and here I will just write stage 04 model evaluation dot py. Now let me just quickly show you the pipeline, the same code. So here I'm just naming this stage like it's a model evaluation, and I'm initializing this evaluation pipeline class. Inside that, I'm initializing my pipeline. As you can see, this pipeline I'm initializing. And once it is done, I also need to call inside my main function. Okay, now this thing I need to call inside my endpoint. But here I think I need to give model evaluation, MLflow evaluation. Now I think it's fine. Okay, now I will call this thing inside my main.py. So main.py. First of all, I need to import it. My model evaluation pipeline. So it should be stage 04 model evaluation. Now, finally, I will define my model evaluation stage. That's it. So guys, now I think everything is fine. So now what I will do, I will just quickly remove these are the experiment I have done, because this was I was doing. I was not sure about like I was training the model or not. Okay, so all the parameters are same. So what I will do is just quickly save, like select everything. I'll just delete. Okay, done. Now if I refresh, see guys, there is no experiment. Now I will go to my code again. Now let's execute my code one by one. But first of all, what I will do, I'll remove this artifact, and I will open my code, and let me open my terminal. Let me clear. So first of all, I will try with my default parameter I have assigned in my params.yaml. I think true. Learning rate is equal to 0.01. I think learning rate is equal to 0.001. Let me just, yeah, 0.01. And yeah, this is my default parameter. I think I am using from very scratch. Now let me execute the code. I'll just write python main.py. Now guys, see the magic and see the power of MLflow. See, it has started downloading the data. Now I'll wait. Okay. When it is done, I will come back. So guys, as you can see, execution is done, and it is also telling it has also registered my model and tracked experiment, and this is the code I got here. As you can see, this code. So now what I will do, I will go back I will go back to my MLflow, and if I refresh it, you will see the experiment. Okay, and it is done in it is done like 2 minutes ago. Now what I will do again, I will do another experiment. So I will just go to my params. Now I will take my epochs is equal to 2, and let's take or let's just take epochs is equal to 2. I don't want to change my learning rate. Now you'll see my accuracy will improve, I think. Now what I will do, I'll again open my terminal, and let me clear it, and again I will execute my main.py. See, that's how you can do different experiment. Okay, and after that you can select your best model out of it using MLflow. Okay, it will give you the graph and all, everything you can see. You can visualize the graph, everything you can do it, and you can pick up your best model. And if you have watched that particular video, I think you already know, okay, how powerful MLflow is. So guys, if you see it's completed, now let me check my score. Now I think, see, accuracy is improved and loss is also decreased. Now let me refresh here. See guys, 2 version of the model. Now let me do one thing. Let me train another version of the model. Okay, let me train another version of the model. So then I will show you the comparison. So what I will do, again I will change the parameter here. Now let's take epochs is equal to 3 or learning rate is equal to 0.2. Now let's see what happened. Now I'll open my terminal, clear it, and execute the code again. So guys, it will take some time for you. Just try to wait unless and until this execution is completed. I'll just pause the video. When this is done, I will come back. So guys, it's done. Now let me see my score again. Yeah, accuracy has been decreased again. Okay, because I changed this learning rate. I think that's why. Because learning rate, this is the default parameter you always need to keep, which is nothing but 0.1. Okay, now I just replace these are the values. Just wanted to show you different experiment with different difference value. Okay, now if I just compare, let me select all the experiment, and I will just do the comparison. And here I want everything. Let's say image, batch, include, top, class, weight, everything. With respect to that, I also want to see my accuracy and losses. Now see guys, try to figure out the best model from here. So what is the best model? Here if you see here, loss should be decreased, loss should be very less. So here I can see this loss is very less, accuracy should be very high, this one. Now just try to figure out this model. Actually I think it's epochs is 2. I think this one, epochs is 2, learning rate 0.1, and here, yeah, learning rate 0.1, image size the same image size, batch size same image batch size, classes. Okay, that means this one, I think yeah, epochs is 2 and learning rate is 0.1. This is the model I'm getting the higher accuracy and lower loss. Now let me figure out that model. So how I can figure out, here you can see, so epochs is 2, epochs is 2, and learning rate is 0.1. Okay, that means this the middle model, this model actually. So I'll open this model. Now let me see the parameter again. So epochs is 2, learning rate 0.1. Okay, and this is the best matrix it is giving, which is nothing but 0.92. That means 92%, and loss is very decreased here. So now guys, I can use this model, and I can use this parameter here. Okay, I can use this parameter. Now I'll open my code. And here I'll just give epochs is equal to 2, because I can see with epochs is equal to 2 and learning rate is equal to 0.01, I'm getting better model. Okay, see, that's how instead of doing hyperparameter tuning, you can do different experiment as a data scientist, and you can figure out the best model out of that. Okay, and this is the power of MLflow. Using MLflow, you can do it very easily. Now you can also see the model it has tracked. Now click on the model, and you can see I have 7 version of the model so far. See guys, all the 7 version model you can see, And I think you remember I added version 1 is my staging area, so it is still running. So I think version 6 was my this model is working fine. I think if I show you, okay, so let's say this is my model is working fine, which is nothing but my model 6, this version. I'll just click on this model 6 and I will add it to my production. Now here status should be production. Okay, production. Now if I go back to my model, you will see my model 6 is running in my production. Okay, and I can also remove this model from the staging area. So just click here. Now I'll click on archive. So this model will be deleted. Now I will see my model is running on the production and there is no model inside my staging area. So see guys, using MLflow we can do this thing. Even using MLflow we can directly do the deployment. Let's say whenever I'm giving this model to the production area, this model would be automatically pushed to my let's say if I'm using AWS for the deployment, it will automatically push to the AWS. That kinds of pipeline we can also able to create here. So I'll bring some more project in future. I will show you like how we can do it. Okay, as of now I think you have learned like how to do the experiment tracking and how to do the model registration. Okay, how to change it to the staging and production area. Okay, and this video will help you guys. Just try to watch this video I'm telling again and again to understand this MLflow in a better way. Okay guys, so this is all this evaluation with MLflow, and I think you got it, like how to track the model, how to track the experiment. Okay, different experiment, and this stage has been completed. Now I'll just do, quickly commit the changes, but before that in the readme what I will do, I'll try to add this video. Okay, I'll try to add this video as a prerequisite so that you can get a reference. Here in the MLflow, tutorial, and here is the link. Okay, now let me just quickly commit the changes. Model evaluation version added and MLflow added. So guys, now let's go back to my GitHub and let me refresh here. See guys, I think everything has been updated here. Okay, MLflow tutorial, there should be a one space. So what I can do, I can give one space here. Okay, now I'll again do the commit, update. And it is coming like that because I'm using git lens. Okay, just you can also install git lens from extension. You will also able to see the color. Now if I again refresh, I hope, yeah, MLflow documentation, MLflow tutorial. So guys, my training pipe is completely ready. We are able to train the model. Even we are also able to track the model experiment and everything. So guys, we completed our all the components and it's working fine. I think we have already executed all the code. Now guys, what I'm going to do here, I'm going to add my DVC pipeline here. Okay, so why I will be using DVC here? Here I'm going to use DVC for the pipeline tracking. So what is pipeline tracking guys? Because if you see here, whenever I'm executing my main.py, that means main.py is connected with my pipeline. Okay, so whenever I'm executing this main.py, so first of all, it is executing my data ingestion pipeline. Then it is executing my prepare base model. Okay, then it is executing my training. Then after that, it is executing my evaluation stage. That means all the component is running one by one. Okay, if this file is also present inside artifacts, let's say data ingestion is already ran and data is also present. Again, if I execute main.py, it will run again this data ingestion. Again, it will download the data. Okay, so what is happening actually? I'm just unnecessarily downloading the data again and again. Okay, again, if you see here, prepare base model is also running. Okay, if you see here, prepare base model is also running. Then after that, my training is also running. Okay, if you see here, training is also running. So basically what is happening here, if my artifact is also available, okay, if there is no chance, everything is available, but after running this main.py, my all the components is running again and again. Okay, my pipeline is running again and again. So that is the major issue whenever you are developing this kinds of end-to-end project, because if you see the execution time, it will take some time, because it will first of all train the model, then log the information to the MLflow. So it takes time, right? But let's say if everything is updated already, so why you will be training this thing again and again? Okay, can we track this pipeline? Okay, like the git we do, right? We do the version controlling. Let's say this file I have already written the code. Okay, I already commit the changes. So if I'm trying to again commit this file, so it won't be allowing me to do the commit, because it will tell this code is already updated. Okay, there is no change in the code. So that is why it's kinds of git only. Okay, whenever I'll be using DVC, so using that, actually you can also do the pipeline tracking. So it will track the pipeline, so which pipeline actually you have executed and it is available or not. Okay, all the artifacts are available or not. If it is available, if there is no chance, that particular stage actually it will skip and it will run the next component. Okay, let's say next component is not updated, it will run the next component. Let's say my prepare base model is not available, only my data ingestion is available. So what it will do, it will skip the data ingestion part and it will run the prepare base model part. So that's how our entire DVC works. Okay, we can use DVC for the pipeline tracking, and the full form is DVC is like data version control. Okay, you can also do the data version control. Okay, data version control you can also do. So in future I will bring some more projects, so there I'll show you how we can do the data tracking, but here I will use this DVC for the pipeline tracking. Okay, so now what I'm trying to say here, let me just give you one demo. I think it would be clear. Now let's say I'll try to execute this file again. Okay, let's say my all the artifacts are available, my data ingestion, my prepare base model, my training, even my model is available, even this JSON matrix is also available after running this evaluation stage. Now let's say if I again execute my main.py, so let me open my terminal. So if I execute my main.py, just see what will happen. So I'll just write python main.py. See, although my artifacts are available already, now again it is downloading the data. If you see here, it is again downloading the data and it will replace the same data file here. So guys, that is the issue. See, all of the artifacts are already available from each and every component, but it is again running the code. So what is happening, guys? You are unnecessary running your code, and you're wasting your computation, right? So that is the issue, and it will take time again. So now what I will do, I will use DVC, and I will write some like YAML command there, and you will see like how beautifully it will track all the pipeline. Okay, how beautifully it will remember everything, like which file you ran. Okay, what are the things has been generated, everything it will track. Okay, and it will reduce your effort. Okay, this kinds of training effort, and it will also reduce the time. Okay, you will be executing your code. I'll show you guys. So let's wait. So once it is completed, I will come back. So guys, as you can see, it has executed successfully. And see guys, although I have everything, but again it has executed all the pipeline one by one. Okay, so this is the like major issue. Now if you visit like Daxhub website, just search for Daxhub. Oh, sorry. Now if you visit your DVC website, DVC. So this is the website dvc.org, and this is the home page. DVC. Okay, this is the home page of the DVC. Now here if you see, DVC is an open source Git based data science apply a version control to the machine learning development, make your repo the backbone of your project, and instill best practice across your team. Okay, so basically it uses Git in the backend. Okay, like you need Git to run the DVC, and it applies the version control technique, okay, to your machine learning or deep learning projects. So what is version control technique? I think you already know in Git. So you can apply this version control technique in two way. One is on top of your data, another is on top of your pipeline. Okay, so here we'll be using the pipeline one because I want to track my pipeline. Okay, and everything they have given, like what are the things actually you can do with the DVC and all, and how to install it, all the documentation. If you go to the documentation, all the installation guideline, everything they have given. Okay, so to install this DVC, I think you remember we have already added this one. Let me show you. Let me just Hmm. Hmm. So in our requirement.txt, we have add this DVC. Okay, now it has already installed the DVC in my system. Okay, now what I will do, here one file I have created called dvc.yaml. I will open this file, and here I just need to mention some of the command. Okay, what are the commands I need to mention? Now let me show you. So if you visit their documentation and guide, you will see they have mentioned the get started command and all. But let's start with our um, project one, because this is a simple just a YAML command you just need to write here. So here the first thing, uh, which pipeline I'm running, guys, just try to consider. If you see here, first of all, I'm running my data ingestion. This one stage 01 data ingestion.py. This is our first component. This is our first pipeline. Okay. So first of all, I need to add this stage. Okay, I need to add this stage, and to run this stage. Okay, what are the dependency I need? First of all, let me show you the command I prepared. So this is your data ingestion stage command. So here, see guys, what are the things I'm mentioning? I'm telling this is the stage. Stage is nothing but my data ingestion. Okay, data ingestion stage. And what is the command? I'm executing this file actually. If you see, called stage01 data ingestion.py. If you see here, it is present inside CNN, then CNN classifier. So it is present inside src, then CNN classifier, then inside pipeline I have this file, and I'm running the command. If you see Python, if I execute this file, so basically it will run this file for me, and if I'm running this file, it will ingest the data. Okay, I think you remember I have already added this main function, that's why. Okay, just for the DVC. Now once it is done, once you will execute this file, so what is the dependency you need to execute the file? Okay, so here I have mentioned it is dependent on this data ingestion.py. Basically, whenever you are running one particular file in DVC, it will depend upon the same file. Okay, it will depend upon the same file, because let's say this file is not available, then how it will execute? So that's why in the dependency you need to add this file itself is the dependency of this file. So again, I'm adding src CNN classifier pipeline. Inside that I have data ingestion.py. I'm just telling this is the dependency of this particular file if you want to execute it. And another dependency, I think you know, I'm depending upon this config.yaml, because here I have mentioned my data ingestion related configuration. Okay, so this is I have added here config/config.yaml. So basically, what are the file you have dependency to run this to execute this file? You need to add inside the dependency. It may vary with respect to your project. So here the project I have designed, it is depending upon only these two files. Fine. Now I think you got to know like how you need to write these are the DVC command. It's like very simple. Only just need to understand to execute one particular pipeline, what would be the dependency and what would be the output. Okay, now what is the output? Here if you see out, so it will generate this one data ingestion and kidney CT scan image, right? So here I mentioned artifact/data ingestion kidney CT scan image. That's it guys, that's it. This is the dependency only you need to add here, and this is the command you need to add here. So this is for my data ingestion. This is for my data ingestion. Now I need to write for my next one, which is nothing but prepare model. Now I already prepared for my prepare base model. Now let me just show you. If I show you this one, I think this should be pretty much clear guys, like what are the things I'm adding. So now I should align with this data ingestion one, because this is my prepare callbacks one. Now I should align it. Yeah, I think everything is fine. Make sure you are adding inside stages. Okay, stage, this is my data ingestion stage, this is my prepare callbacks, prepare base model stage. Now see guys, first of all, what I'm doing, I'm just executing this file, prepare base model. If you see Python src CNN classifier pipeline prepare base model.py, then what is the dependency to execute this file? I have dependency of this file itself only. Okay, this file I need to add, and it is also depending upon the config.yaml, because if you see here, prepare callbacks taking some of the configuration from this config.yaml. Okay, then it is also depending upon some parameter. Okay, if I open this params.yaml, see guys, I think you remember whenever I was preparing my base model, I was taking image size, include top, classes, weight, and learning rate. So that is why I'm just telling params, and inside params, what are the parameters actually I was using? I have just mentioned it here. And what would be the output? The output would be this folder prepare base model. Here if you see prepare base model, this should be the output. Okay, simple thing only guys, just you need to understand like how to add the command. That much simple like this DVC is. If you understand this like flow, you can integrate this DVC with any kinds of project you will be doing in future. Okay, that's it. Now what would be my next stage? Next stage is nothing but my model training. Now let's add it for my model training. So here just let me add. Okay, so this is for my model training. Now again what I'm doing, I'm executing my model trainer EVC here. I think it should be model training.py. Let me just rename the name until C. So again I'm running the command stage 3 model trainer training.py. Then it is depending upon your this file itself called model training, and it is also depending upon I haven't used callbacks here, so I can remove it here. It is depending upon this config.yaml. Okay, config.yaml, because again I'm reading the configuration, I think, remember, for the training. Now it is depending upon your data also, like whenever you are training your model, right, you are training your model, it is also loading the data, I think you remember. So it is also depending upon this kidney CT scan image, that is why I have added. Then it is also depending upon the prepare based model, because it is also loading the model, I think you remember this model it was loading, so it is also dependent upon the prepare based model. And what are the parameters it was using? Image size, epochs, batch size, and augmentation. I think you remember whenever I was doing the training, it was depending upon these are the parameter. Again I'm picking up from my parameter itself. And what is the artifacts it is generating? Output, it is generating this model.h5 inside the training folder. That's it guys, that's it. Now let me save it. Now what was my last one? Last one is my model evaluation one. Now let me add the model evaluation one, and this is my last one. And if you add it, so you are able to integrate the DVC pipeline with your code. So yes, this is my model evaluation. Again it is running, I'm executing this command model evaluation. Then it is depending upon this model evaluation itself. Then it is depending upon the config.yaml, and it is also depending upon the CT scan image, because again it was loading the data, it was doing the evaluation, right? And it is also depending upon the model file inside my training, because it was loading that model, my trained model, right? And parameter, again it is what is depending upon image size and batch size. And metrics is what generating called score.json, I think you remember score.json it was generating. And once it is done, once all the like component or all the stages you have added, you need to give this catch is equal to false. Okay, this thing you need to give. Now guys, see my DVC is prepared. My DVC is prepared. Now let me show you how it will track the pipeline. So guys, now what I will do, I will show you the DVC one. So first of all, unexpand, these are the file. Okay, now I'll also unexpand this file. Okay, so to start with your DVC, first of all you need to execute one command. Let me show you the command guys. See, make sure first of all you have the git present. Okay, I already have git present in my folder, as you can see .git is present. That means I was using git, okay, from very scratch. Now first command you need to execute called dvc init. Okay, if you do dvc init, it will initialize the dvc here. So I'll just clear my terminal, and here I'll just write dvc init. Now if I do dvc init, you will see it will initialize dvc here. See, it has initialized one folder called .dvc, and it has also initialized this .dvc ignore. So these are the file would be generated after running this command. Okay, the next command what I will do, I will run this dvc repro command. Okay, dvc repro command. But before that, what I will do, I need to delete the artifacts. Okay, I need to delete the artifacts, because I just want to show you, like once it will run the pipeline, okay, entire pipeline, then if I am running it again, okay, it won't be running the pipeline again and again. Okay, so for this what I will do, I'll just remove this artifact. Just let me remove the artifact. So this is the artifacts I will remove. Then here what I will do, because I don't want to run my MLflow like this code, because it will take time, so I'll just quickly comment that line. So I'll go inside my src and CNN classify, then I'll go to the pipeline and MLflow model evaluation. So log into MLflow, this line I'll just comment it out. Okay, just to quickly show you, like I don't want to execute this file, I'll only run till save the JSON. Okay, it is like it will only save the JSON file. Okay, and I don't want to like log the information to the MLflow as of now, because it will take time. Now what I will do, I'll just write, I'll open my terminal. Let me clear it again. Okay, now see guys, my artifacts is not there. Now what I will do, I will also delete this score.json, because it is also available here. Okay, fine. Now I'll execute this command called DVC repro. See guys, this is the command. If you execute this command, basically it will run this dvc.yaml file. It will go inside dvc.yaml file. It will run this dvc.yaml file, and this dvc.yaml file, it will run this pipeline one by one, because you have mentioned all the command here, right? So this is the convenience of writing this YAML file. Now let me show you. See guys, if I run this DVC repro, now the first pipeline has started my data ingestion, and see guys, my data is downloading. And it is also tracking, guys. It is also tracking my data is downloading to this folder. Okay, what is with the dependency, what is with the artifacts, everything it will track, so that whenever you will be running for the second time, okay, if there is no chance, it won't be running. Otherwise, it will run. Just let me show you guys. Let me complete it. Okay, then I will show you. Now see guys, data ingestion is done. Now prepare base model is running. Okay, see how beautifully it is tracking. Now prepare base model is done. Now my training is running. If you see running stage training, and my training is happening. And in the artifact, if I show you my artifact, inside artifacts, all the things has been generating. Okay, now just let me finish it. Okay guys, so it is giving one error, telling cannot find this file, stage04 evaluation.py. Just let me check. Okay, sorry guys, I think it should be model evaluation. Let me just copy the name and give it here. It should be model evaluation. This is my bad. It happens actually whenever you are writing code, so it happens sometimes. Okay, now everything, I think it's fine. Now what I will do again, I will delete my artifact. Now again, I'll try to execute the code. I'll open my terminal. Let me clear. Now let me run this DVC repro. So again, data ingestion started. So guys, you can see execution is done. Now if I open my artifact, see my data has been downloaded. If you see this kidney CT scan, everything it is downloaded, and prepare base model also downloaded, and a model is also trained, and my matrix of JSON has been also generated. See guys, okay, now it is able to running successfully. Now let's say all the files are available inside my artifacts. Okay, all the artifacts is available from all of my component. Now if I want to again execute this, let me first of all clear this DVC repro. Now see what it will tell. So it is telling stage data ingestion didn't change, skipping. Then prepare base model didn't change, is skipping. Okay, then training is skipping, evaluation is skipping, data and pipeline are up to date. Okay, that means here if you see, it has created some additional file called dvc.log. Okay, so inside that it has tracked everything, like what are the things it has like executed, everything it has tracked, like all the metadata it already has, even with the file size, okay, file name, everything it has tracked. If you're not changing anything inside the file, then it won't be running that particular file itself. Okay, that is the power of DVC. Now here, let's say I will just remove this one, prepare base model I will remove. So let's say this is not available in my pipeline. Now what will happen? If I again execute this DVC repro, it will skip my data ingestion. But if you see here, prepare base model, it is running. Okay, it is running now. Again, I got my base model. Okay, and again, train model was there. That's why it is again skipping. I think you can see here, it didn't change, skipping, and evaluation also didn't change, is skipping. That's how, if you're not doing anything changes in your code, okay, if you're not like many changes in your code, or let's say in your pipeline, it won't be running the pipeline. It will skip every time. Let's say if you run 1,000 times, it will skip. Okay, if I'm running 1,000 times, it will skip. Okay, it won't be running. That's how I can save my time. I can save my computational power instead of doing unnecessary training. Because I was showing you, whenever I wasn't using my DVC, it was running the entire code again and again. But now I'm able to track my pipeline. So this is the power of DVC, guys. Now I think you got it. What is pipeline tracking? So using this one particular file called dvc.yaml, we are able to track the entire pipeline. Okay. Now whenever you are executing your code, don't try to run the main.py. instead of running, just run this dvc.yaml, that means dvc repro. This command you need to execute, but we won't be training our model again and again. Okay, always we won't be training. So whenever you are training your model, at that time just try to run dvc repro command instead of running main.py, because main.py is a simple Python file, but dvc.yaml has the dvc integrated with that, right? So I think you got it, guys, what you need to do here. Now, yes guys, this is the dvc part, and we are successfully able to integrate that. Now let me just quickly do the commit operation. So what I will do, I'll just do the commit, and make sure whenever you are executing this code, you just remove, these are the thing, dvc lock, then dvc ignore. Okay, these are the file you just remove, and only just keep this dvc yaml file, and rest of the thing you can remove, okay, from your repository. Then try to run it, because this is my code, I'm just committing here just for your reference. Now here I'll just give the commit dvc add it. dvc added. Okay, and also try to uncomment this one, uncomment this evaluation log into MLflow. Whenever you are trying to experiment your MLflow, you can like uncomment this one to see the log inside the MLflow. But as of now, I've commented just to execute the code very fast. Okay, but as of now, I've just committed this line because I want to show you the quick execution. That's why. Okay, and make sure you are changing, these are the URL, your own URI you are using. Just try to create this URI using your DAXUP, and try to use your own URI. Don't use my URI, otherwise it will throw error. And make sure whenever you are executing MLflow, okay, whenever you are running this pipeline with the like after you can say uncommenting this line, make sure you are adding this command again and again. Export, just try to export these three things. Okay, I think I already showed you. You need to export it. Let's say you have closed your system. Okay, you have closed your system, you have also closed your terminal. So whenever you will open in second time, you need to execute this particular three command, otherwise it will throw error. Okay, so make sure you are running this three command. Okay, now I think it has committed. Now if I go back to my GitHub, now I'm able to see my dvc. Fine. So yeah, everything is running fine. So let me add, these are the dvc command as well in the readme file, just for your reference. So after MLflow, I will add the dvc command. Now let me commit the changes again. Update it. Done. Now let's go back and say refresh. See, dvc command I have already updated. Now see, one particular things, guys, I just forget to tell you, dvc dag command. So what is dvc dag command? Let me show you. See, it will show you the entire graph, actually entire pipeline graph. So if I just run dvc dag, see guys, you will see, like, see the pipeline. See guys, first of all, it has run the data ingestion, and data ingestion is depending upon what? Data ingestion is depending upon model evaluation and training, because to execute training you need data ingestion, that means data unit, right? And to do the evaluation you need the data. And prepare based model is only depending upon the training, because training needs the base model. Okay, and prepare based model is doesn't need like data ingestion and evaluation. So this is the graph, actually you can see. By seeing the graph you can easily tell like what is the dependency of your pipeline. Okay, so this is one beautiful thing they have created called dvc dag. Okay, I hope you get it. So guys, now let's try to add our prediction pipeline and user app, because we completed this dvc and all. Now only prediction pipeline and user app is left, because let's say if I'm giving this app to any kinds of user, so they should get one UI, okay, to upload the image and get the prediction. So these kinds of functionality I will add in this code. So now I'll open my code, and here first of all let me close these are the thing. Okay, so inside pipeline I will try to create another file called prediction.py. Now here first of all I will import some of the libraries. So these are the libraries I need. I need TensorFlow, and from TensorFlow I need load model and this image. Okay, because the image actually user will pass that image should be like pre-processed, okay, using this keras. Now here I'll define one prediction pipeline class. Okay, this is the prediction pipeline class. So whatever image user will pass, I will receive it here. Okay, then I'll just write one predict function. This is a simple prediction code. If you have done the image classification, I think you already know what I'm doing. See guys, so here I've written one predict function. So first of all, I'm loading my model. If you see, I'm loading my training model, H5 model. Then image I'm receiving. If you see, image I'm receiving, use the image actually user is giving, I'm receiving that image. Then what I'm doing, I'm just loading the image, okay, with the target size, because I mentioned my target size 2 to 4, 2 to 4. Okay, this is the target size, and I'm converting to numpy array. After that, I'm expanding the dimension. Then I'm just doing the prediction, as you can see. Then I'm taking the argmax. That means it would be softmax, right? Softmax output. So I want to take the argmax. That means the most probability score. And if it is like 1, so that means it's a tumor. Okay, otherwise it would be normal image. Okay, so that is why, because your model will pass only value. So if it is 1, that means it's a tumor image, and it is 0, that means it's a normal image. Okay, so this is the prediction we are only doing, and we are just returning the prediction. That's it guys. Okay, now I'll try to add this prediction pipeline to my app. So here I'll just create another file in my project folder called app.py. Now I'll be using Flask to create the app. First of all, let me import some of the libraries. So I'm importing Flask, request, JSONify, render template. These are the thing. So you need some knowledge on Flask, guys, like what is Flask and all about. And if you want to get some knowledge on Flask, so just try to visit Chris Naik's channel. Actually, there will get tutorial about Flask. Okay, just try to learn the Flask, like how we can use Flask and all. But I'm expecting you are already familiar with Flask. Okay, at least basics concept. Okay. Now I'm importing operating system package, and I'm also importing CORS origin from Flask. Then here I need to import one thing called decode image. Okay, I think you remember inside my common, inside my utils common, I have written two functions. One is my decode image and one is like encode image. Okay, so basically what happens actually, whenever user will pass one image, okay, whenever user will pass one image from this, let's say this is my UI, user is passing one image, that image won't be coming as a raw image. Okay, it should be converted to base 64 string. So let me show you base 64 guru. There is a website. Now let's say I want to do image to base 64. Let me do it. This is the base 64 to image, and here you also have image to base 64. You can search here image to base 64, base 64 guru. Image to base 64. Okay, now let's say here if I upload one image, let's say I can upload any kinds of image. Let's say I will upload this image. Now if I encode this image to base 64, see, it will return one base 64 string. Okay, this is my base 64 string. Okay, now I'll copy this one and I will go back to my base 64 to image. Now if I paste this base 64 and again decode it, so it will convert to my image. See guys, it has converted to my image. Okay, so that's how actually you can do it, this thing. That is why I've written to function decode image and encode image. So the image actually I'm receiving, first of all I need to encode it to the base 64 string. Then after receiving the image as a base 64 string, again I will decode it, okay, here, and it will save the image here. So that's why this two functionality is needed. Then I also need to import my prediction pipeline here. So now let me import it quickly. So I'll just write from CNN classifier dot sorry, it should be CNN classifier dot pipeline import, or there is another prediction, then import. This is the pipeline, prediction pipeline. Done. Now here first of all I initialize my Flask. Okay, then I'll create one function called client app. So whatever image user will pass, I will save it as input image. That's why I'm giving the file name, and here I'm preparing my classifier. Okay, as you can see, if I'm calling my prediction, okay, and what prediction take your file name. Here I'm giving the file name, and here I'm getting my classifier object. Now what I'm do, first of all, I will create my default route. So this is the default route. Okay, this is the default route slash, and it will render your index.html. Now let me open the index.html. I think inside template I've created index.html. Now inside that you just need to mention some HTML code. Okay, now what kinds of HTML code you need? So here I already prepared some basics HTML template. So you don't need to learn the HTML here. I already prepared for you. You can use my template as it is. So yes, this is the HTML code I prepared. Okay, HTML code I prepared. And from where I referred this code, just there is a website called Bootstrap. Bootstrap, if you visit, so it has already all the template, what kinds of template actually you want. So here I've just only created one image uploader. So here they have the documentation. So you can get started with. Otherwise, they have also have given some example. Let's say this is the template they have given. You can also refer the template. So I already prepared one template for you. I'll show you like what kinds of template I prepared. So this index.html I'm launching. Then after that, first of all, I will create my training route. Okay. So user can also train the model. So if they're giving /train, that means my training will start. Okay. This pipeline will start. So here you can also give like that DVC repro command instead of pipeline. Instead of like running main.py, you can also give the command like that DVC repro. If you want to track the pipeline, then you can execute this command. But if you want to execute, okay, the main.py, you can give this command. Both I have given. Now it's up to you, whichever you will be executing. Now let's comment it out one. Okay. Now this is your training pipeline. Once training is done, it will tell training successfully done. Now I also need to add my prediction route. And I also need to initialize my client app, and here I'm going to do the deployment for the AWS. So this is what I will keep. So this is your host and this is your port number. With this port, actually your app will run. Now guys, I think everything is done. And we are also, see, in the prediction route, what I'm doing, I'm taking the image from the user. I'm first of all decode the image to the base 64. Then in the backend, it will again apply the encode operation and it will save as a JPG format. Then I'm doing the prediction. Okay. Then I'm returning the result as a JSON file. Now let me run and show you. So I'll open my terminal. Let me clear it. And I'll just write Python app.py. Now app.py should be your endpoint. See, my app is running. Allow access. Now I'll visit this URL. It's running 8080. I'll go back to my Google and I'll just search localhost 8080. Now see guys, here my classifier is running. Now let me first of all upload one image. So I'll upload this kidney image. Inside artifacts, I have the data. Let's give first of all normal kidney and predict. So it's giving normal. Okay, now let's upload my tumor kidney also. See guys, it is predicting as tumor, and this model won't be very good because I just only trained one epochs, and again you need to increase the epoch size because loss was very used there, right? So it's running fine guys. I think you saw this project is running fine for me. So yes guys, we have completed this project. Now we only need to deploy this project because all the things we have added. Now what I will do, let me just push the changes quickly. So I'll just write prediction added. Yeah, it's done. Now next what I will do, I will add the Docker file and I will also add this CICD step. Okay, then I will try to do the deployment this application to the AWS cloud. So guys, our project is ready. Now we can deploy this project to the AWS cloud. But before that, I have done some slight modification here. So let me show you. So what I did here, because see, artifacts actually I'm not committing in my GitHub. That's why artifact won't be uploaded. If I show you my artifact, see, there is no artifact folder. But in the artifacts, actually, I have my model. Okay, but let's say after doing the deployment, you want to do some prediction. So there actually, if your model is not available, so this code will give error like this model file not found. So what I did actually, I created another folder called model. inside that I just kept this model. Okay, I just kept this train model. If you see here, train model, and in the prediction pipeline, instead of loading from my artifacts, I'm loading from this folder itself. As you see here, I'm just giving model and model.h5. Okay, so now my model, here I'll be loading my model and I will be doing the prediction. Okay, so that is the slight modification I have done. Now what I will do, I'll just quickly commit the changes. Model added. Now you will see this model folder would be uploaded in my GitHub. Okay, see, one particular update actually you can do in this project. I will give you this thing as an like assignment task. So once you are training this model, okay, this model.h5, just write a Python script. Okay, like after training, use like Python inbuilt, or like you can say external package to copy this model.h5 in this folder. Okay, there should be some package I think you can use. So using that package, actually you can directly copy this model h5 to this model folder. Okay, I have just done it manually. So if you know Python, I'm expecting I think you will be able to do it very easily. Okay, just a simple copy operation you just need to do. Copy this model from this folder to this folder only. Okay, so this thing would be automated that time, but here I just kept manually. Okay, just to show you, okay, how we can do the prediction itself if you're not uploading your artifacts, because artifacts will have also the data, right? So this data actually I can't push, so that's why I kept this model as separate. Now if I go to my GitHub and refresh the page, see guys, my model folder is available. Now inside that I have the model. Okay, now yeah, it's working fine. Now if I show you by running this application once, I think it should work. Let me clear the terminal. I'll just write python app.py. Now let me open this link. Yeah, now let me upload one image. Now let me do the prediction. See guys, it's working fine. Okay, it's working fine. And let's see, if you want to train your model, what you can do. If you see in the app, I have given this training route. Okay, this training route I have given. So you just give /train here. If you give /train, then press enter, it will start the training again. Okay, it will run all the pipeline. So I'm not going to train because it will again take time. You can test from your side. Now what I will do, I'll just quickly write my Docker file and the CICD.yaml file. Then I'll try to do the deployment. So here what I will do, I think Docker file I don't have here. I need to create Docker file here. So let me first of all unexpand. These are the thing. Okay, so here first of all I'll be creating one file called Docker file. Okay, so in this Docker file, I just need to write some particular command like Docker command. So it's a very simple Docker command. Let me explain what are the things I have just written here. See, first of all, the Python version you are using in your project. So in this case, actually, I was using Python 3.8. I think you remember. So this image actually I'm taking called Python 3.8 Slim Buster image. Okay, this is the Python image. First of all, it will download the Python image. Okay, Python interpreter. Then what I'm doing, I'm just installing like AWS CLI here, because I'm going to deploy my app to the AWS cloud, and there actually I need this AWS CLI. Okay, CLI, that means it's a terminal. Now here I'm creating one directory called app. Inside that I'm copying all of my source code. Okay, inside this app, then I'm running this requirement.txt because it will install all the requirements. Okay, in the environment we will be creating in my deployment. Okay, there. Then what it will do, it will run this app.py because app.py is my endpoint. And here if you see, I have already mentioned my host and port. Okay, so that's it. This is the simple Docker file I've just created. Now what I will do, I'll create another file inside .github, inside workflows. So let me quickly create it, called main.yaml. So in this YAML file, I'll be writing all of my CICD command. Now I can remove this .git keep. It's not required. Okay. Now I already prepared this YAML command. It's just a simple command. Okay. So you don't need to understand this command and all. You will get this code in the internet itself. Just search like how to do CICD deployment using GitHub action with AWS. Okay, you will get this file. Now here I have just done some slight modifications. So here I'm doing actually continuous integration, continuous delivery. In continuous delivery, what I'm doing, I'm just connecting with my AWS. Okay, there actually I was installing some of the necessary libraries. Then I'm logging with my ECR. Okay, I'll tell you what is ECR and all. Then I'm just building my Docker image. Okay, then I'm pushing this Docker image to my ECR. That's it. And in continuous deployment, again, I'm logging with my account and pulling the image from my ECR and running inside my EC2 machine. Okay, so that's it. So this is the just modification I have done in the code. Now what I will do, this is the file you need to add there. Now I think everything is fine. You don't need to change anything. Okay. Now let me show you the deployment steps actually are the following. So let me write it down in the readme.md file. So here I'll just mention my deployment step. Yeah guys, see. So the first thing here, I think I mentioned deployment step. First thing, we'll be building one Docker image, okay, of our entire source code. So that is why I've created that Docker file. Then I'll push that Docker image to the ECR. That means Elastic Container Registry. So this is the service from AWS. It's kinds of Docker hub only. Okay, so there actually we can store Docker image. Then I will launch one EC2 machine. Okay, EC2 is a virtual machine. Then I'll pull that image from ECR to EC2. That means I will be pulling that image from ECR to EC2 machine. Then I'll launch my Docker image inside EC2 machine, and it will be running. Okay, at that time I'll be doing some like port mapping. Then I will be able to access my application. Okay, that's it. And for this, I need this two policy. Okay, I'll be showing you like how we can add the policy and all. And here I've just mentioned all the command you need to execute there. Fine. Now what I will do, I'll just quickly commit the changes again. Because see, the GitHub actually I'm using, this is Krishna XR GitHub. Actually, from here I can't do the deployment. So this thing I will bring in my GitHub repository. Then I will show you from there because I can't access our account. Okay, so that is why I'll update the code here. Just for your reference, you will get the code from here only. Then I will show you like how to set up your account. Okay, set up from your account. Now what I will do, I'll just quickly push the changes. So here I'll just write CICD added, CICD added. Fine. Now let me go back and refresh. I think yes. So all the deployment steps, everything I have added here. Okay. So you can refer the command from here only. Now what I will do, I will just move this code to my GitHub. Okay. Then I will show you the deployment. So guys, you can see this is my repository. Okay. I just like moved the same code here. And now I'll just show you like how we see. Now we have this option actually settings and all, but previously if I go here, I don't have the option because this is the SAR channel, because this is the SAR account. Okay, that's why I can't access this account here. Now actually I will be able to access everything from here. Now what I will do, let me show you one thing actually here. Yeah, so see, whenever you are doing the deployment at that time, I think you remember in our pipeline, let me show you the pipeline. In this model evaluation, so there actually I added the MLflow. Okay, MLflow code. This thing you need to comment out because see, only MLflow experiment we'll be doing whenever we are building this project. Okay, in our development stage. Okay, whenever we'll be doing different experiment, at that time we'll be activating this thing and we'll be training our model. But once I got the parameter, okay, once I got my real parameter, okay, like what are the parameter actually is suitable for this data. Okay, once I get it, I don't need this MLflow. So that's why I've just commented out. Okay, now I'll do the deployment. So make sure you just take care. These are the thing. Okay. Now what I will do, the first thing I'll be logging with my AWS console. So this is my AWS console, guys. I have already logged in. You just also log in with your AWS console. So here, first of all, let me show you the deployment steps. Actually, I'll be following here. Yeah. So first of all, I need to log in with the AWS console. I already logged in. Then I need to create one IAM user for the deployment. Now just click on this home page and just search here IAM. Okay, that means Identity Access Management. Because I don't want to give all of the service, okay, like to my user. Actually, they if I am giving, then they will be able to access, and again it's costly. So I don't want to like increase the cost. That's why I only will give that. These are the permission only. I need this for the deployment. Okay, so here I'll click on the user, and I'll just create one user here. I'll give this username as, let's say, kidney. I'll give the project name only. Then I'll click on next. Then here it is telling just add permission. So just click on attach policy. Now here I already given the policy you need to add here. So these two policy you need to add, just copy one by one and search here. I'll add it. Then after that I'll just remove here. Then again I'll copy the second one. Then I'll give it here. That's it. Now I'll click on next. Then create user. If you see, these two policy has been added. Now create user. Okay, my user has created. Now I'll go to the user and collect my secret credential actually. So click on security credential and here you will get access keys. Okay, now create access keys. So these keys actually I need to access my account. Okay, I need to add in my secret, and don't share this credential with anyone, otherwise they will also able to access your account. So I will delete this credential, okay, after just recording the video. That's why I'm showing you. Now I'll select command line interface, then I'll click on next. Okay, I need to confirm this one, then I need to next. Now everything is fine. Now create access key. Now this is my access key and secret access key. You can also download a CSV file. Let me download. See guys, it has downloaded. Now let me open it. Open. Now see guys, this is my secret access key and this is my uh, access key ID and secret access key. So this thing I need. Okay, whenever I need, I will tell you. Now what I will do. First step I have done. Like I have already created this one. I'm user. Now what I need to do. I need to create one ECR repository to save my Docker image. Okay, now let's go back and click on AWS. And here, now search for ECR. Okay, ECR, that means Elastic Container Registry. This is the service. Now here, I'll just click on Get Started. Now here, just make it as private and give the name. I'll just give kidney. Then again, I'll just create the repository. So kidney has been created. Now you just need to copy this URI. Okay, let's copy the URI and save it somewhere. Actually, I need it. So I'll just save it here in the README. I think I added this URI somewhere. Okay, so this is the URI. You need to save this URI because I need it later on. Okay. Now let's go back and make sure you see your region. So I'm inside AP South one. That means Asia Pacific. Okay, this region. So whatever region actually you are using, try to track it always. Okay. Now this thing also has been done. Like I have created my ECR repo. Now I need to create one EC2 machine. So let's go back and click on the AWS. And here I will search for EC2. So EC2 is a virtual service, virtual machine service. So there actually I'll launch one machine. Now I'll launch instance. And here I'll just give the name. So kidney machine. Then select this Ubuntu machine. And here everything will remain same. Just select the instance type. I'll be taking some bigger RAM here because this is a deep learning project. At least 8 GB RAM I need. So I'll take this T2 large, this machine. Then here you can select key value pair. Just create a new key value pair. So I'll just give name, let's say kidney. Then I'll just create a key value pair and I will select it here, kidney. Okay, see kidney I've selected. Now here what I will do, I'll just allow this to access, and storage I need, let's say I will take 32 GB. I think just a minute. Yeah, it would be 32 GB. Okay, now I think everything is fine. Then I'll just launch the instance. Now I'll click on view instance. Now see guys, status is pending, so this should be running. Okay, then we'll be able to access the machine. Let's wait. So guys, you can see my instance is running. Now I'll just click on this instance ID, and here I'll just do the connect, and I'll make it connect. So it will launch one terminal here, and here we'll be installing all the necessary tool. So this is my terminal. Let me clear it and let me zoom it a little bit. Okay. So here the first thing I will I need to install some. First of all I need to upgrade my apt get. Okay. So this is the command I have given. Just run one by one. It's done. Then I'll copy the second one. Give yes. So it may take some time. Let's wait. So guys, if you are getting this window, just press enter from the keyboard. It will disappear. Yeah, it's done. Then I need to install Docker in my EC2 machine. So these are the commands you need to execute one by one. Let me run it. Make sure you are running all the command. Now I'll copy the third command and run it. Then last command. Now if you want to verify Docker is running or not, just write Docker -- version. See guys, it's showing the version. That means Docker is running. Now what I need to do, I already have installed Docker. Now I need to configure EC2 as my self-hosted runner. Okay, so for this I need to go to my project setting. So this is my project. I'll click on the project setting. Then here left hand side you have one option called action. Click on action, then click on runner. Then here you just click on new self-hosted runner. Now here just select the Linux machine, and these are the command you need to execute one by one. So first of all I'll copy this command. I'll go to my machine and execute it here. And then I'll copy the second one. So basically I'm trying to connect with my GitHub, okay, with this EC2, AWS EC2, so that whenever I will commit my code in my GitHub, it will automatically pull the code here and it will run the code here, okay. So that is what I'm doing here. So using these are the credential, it will connect with your GitHub. So that's why you need to execute these are the command one by one. Then I need to run two more command. So this is the second last command. See, it has connected with my GitHub action. Now it is asking for the runner group. Okay, I'll just press enter. Now it is asking for name of the runner. So I'll just give self-hosted. Okay, make sure you are giving this name, otherwise it won't be working. Self-hosted. Now I'll again press enter. Now again I'll press enter. Now see, it's done. Now I'll just connect with my GitHub. This is the last command. Now you will see it will be connected. See guys, connected to GitHub and listening for the jobs. Now if I go back to my runner, see guys, it's idle. That means it has connected. Now what I need to do, I have already connected as self-hosted runner. Now I need to add my GitHub secret, okay, one by one. So first secret I need to add AWS access key ID. So I'll again go back to my project setting, and here I have this secret and variable. Okay, I'll click on action. Then I'll click on add new repository secret. Now here the first thing I need to add for my AWS access key ID. I'll copy. I'll paste it here. Then access key ID, where you will get, I think you remember we downloaded one CSV file. So this is my access key ID. I'll just copy till comma. And I'll give it here. Add secret. Fine. Now what I will do, I will copy the second one, AWS secret access key ID. Again, I'll click on new repository secret and add it here. Make sure this should be the name, secret key. Now where I will get the secret key, again I will open that CSV file. This is my secret key. Make sure you copy after this comma, okay? Comma is the separator. It's done. Now let me see the next one, AWS region. So for me, I think it's AP South one, because I'm in Mumbai region. AWS region. If you are not sure, just click here. It will show. I'm inside Mumbai, so AP South 1. So this is the name, just write AP hyphen South hyphen 1. Now click add secret. Done. Then I'll copy the next one, AWS ECR logging URI. So where you will get the URI, I think you remember in the README file, we have saved one URI. Okay, this is the URI, just copy till .com. And I'll give the URI here. Done. And last one, ECR repository name. And what is your ECR repository name? So after URI, let me open the README one. After URI, you have this kidney. Okay, this is the name of the URI. So guys, I hope I have added everything. Yes, so I have added everything and it is ready to push. Now I'll go back to my project. Yeah. So here now what I will do, I will go back to my project and I will update one file here. So what I can do here, I'll go back to my project. Okay. So let me update something here, because if I'm not updating, then I would be able to commit. Okay, so I'll just remove these are the thing. So you just make anything update in your code so that actually you will get this commit message. Okay, you can add one comment and anything you can do inside app.py. Now see, commit message is available. Now make sure everything is fine. Let me check it once. My main.py. This one I will delete because this was I was doing for Azure, so that's why this file is coming. Now only you just need main.yaml file, and I think all the commands are fine. Okay, and make sure this 3 line would be commented like at the very first, because there won't be any container running at the very first. That's why I have commented. But once you are deploying for one time, then second time you need to uncomment this line. Okay, so this is the thing. Now guys, I think everything is fine. I can do the push operation. So I'll just write done. Okay, now let me, now if I go to my repository, now if I refresh, you will see one yellow icon. That means my workflows is running. Now I'll click on action, and this is the done. And this commit message is coming because I also did previously, that's why. But for you it will just only coming one. Now see, continuous ingestion is done. Now continuous delivery is happening. Inside continuous delivery, first of all it will install some utilities, then it will configure with my AWS credential. Basically it will log in with the AWS, then it will build a Docker image of our entire source code, then it will push that image to the ECR. Okay, so this is the step actually it will be running inside my continuous delivery. So guys, this step may take some time, depends upon your project size. So in this case, my project size is a little bit big, so it may take some time. So I'll pause the video and I will continue once it is done. So guys, as you can see, my continuous delivery is also done. Now it is running the continuous deployment. So in this stage, actually what will happen, it will pull that Docker image from the ECR and it will launch inside the EC2 machine. Now again, it may take some time. Let's wait. Okay, I'll come back. So guys, as you can see, all the 3 stages ran successfully. That means everything is fine. Now I will go to my application again. And here, first of all, let me check the port I have assigned. So I'll go to the app.py. So I think it's 8080. Yeah, port number 80. Now I need to configure the port. So I'll go to my instance. Let me zoom out. Okay. So here I will go to my instance. This is my instance. Now here you will get one option called security. Just click on the security, then security group. Now here right hand side you have edit and bound rules. Just click here and click on add rules. Now it should be custom TCP and port number it would be 8080. Okay, the custom port we are using, and it would be 000, and everything is fine. Save rules. Okay, then I will again go back to my EC2 machine, running machine. This is my machine. I will come here. Now my machine is running. Now here you will get one public IP address. Now copy this address and paste it here and give the port number 8080. Now your app should be running. See guys, my app is running. Now I can do the prediction. See guys, it's giving normal. Okay, everything is working fine. Now if I'm also like closing this terminal also, like your AWS terminal, it's running, still this app will work. See, again I will upload one image, normal image, and let's do the prediction. See guys, okay, so guys, we are able to successfully deploy our application and it is running fine. And if you want to train it, so you can train it, just give /train, so it will start the training. So I'm not going to train it because again it will take time. Okay, now guys, what I will do, I will also show you how we can terminate the instance, because if you just keep it running like that, so it will charge you. So I'll also show you how to terminate. So to terminate the instance, just go to your EC2 machine again and select the machine you have created and click on the instance ID and terminate the instance. Terminate. So basically it will delete everything after some time. So okay, you see it is shutting down. Okay, now if I refresh the page, okay, it's not there. And now what I will do, I will also delete my ECR. So ECR, I will go to the ECR. So this is my ECR I have created. I'll click here and delete. Then I also created, I think, IAM user. I'll also delete this one. This is my kidney user and I'll just delete it. So that's it guys. Now if I again refresh this page, say it would be running because I have already deleted all the instance. See guys, okay, so yes guys, this is all about our project. So we have started from very basics and we deployed our project also, and I hope you learn like how we can implement these kinds of deep learning end-to-end project and how we can also integrate MLOps tool with it. Okay, so yes guys, I hope you enjoyed the entire video implementation. If you have liked it, just try to subscribe to the channel, try to like this video, try to share this video with your friends and family. So yes guys, this is all from my side, and in future I will bring some more project. Okay, don't worry about. So thank you so much for watching this video and I will see you next time.